Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, ladies and gentlemen. Welcome to Industry Institution Engagement and Educator Summit 2021. My name is Anis binti Misbah, and I will be moderating this session. Okay, before we begin, I have a few housekeeping notes. The first one, during the presentation, if you have any question about the topic, please write the questions in the Q&A box on the screen. And the second one, I would like to request the participants to scan the QR code to record your attendance. Okay, ladies and gentlemen, we are now in parallel session 2, electrical and electronics session. We have 3 speakers this morning, and they are Mr. Eric Lim, Technical Consultant from Techmark Group, Madam Wincy Chan, Microsoft IoT Business and Partner Lead from Microsoft Asia, and Mr. Tan Chi Weng, Senior IoT Solution Architect, also from Microsoft Asia. Now, let's welcome our first speaker, Mr. Eric Lim from Techmark Group. For your information, Mr. Eric has been in test and measurement industry for the past 12 years. He has vast hands-on experience in high-speed digital data test and measurement, signal quality assurance, test automation, solution development, and project management. And also, he has been actively conducting trainings on test and measurement domain, IoT domains, and embedded system in machine learning. So, please welcome Mr. Eric with the title of his presentation, From IoT to AIoT, AI as the Catalyst to IoT Implementation. So, Mr. Eric, the floor is yours.
Thank you so much. My name is Eric. A very good morning to all of you today. I'm the technical consultant or the application consultant for Techmark Group. So Techmark Group, we are a technology solution provider. We provide test and measurement solution, IoT solution or AI solutions to the industry, to the government sector and also to education sector. So definitely KKTM is one of our good partners, including MJII. I remember we had a few collaborations in the past, and definitely this event today is something I'm really anticipating. So without further ado, let's move on to the topics that we want to talk about today, from IoT to AIoT. Now, of course, later we're going to talk about what is AIoT. IoT, I believe, is no longer a new term to all of us. I remember very clearly, like 5 or 6 years ago, when we started to see a hype in terms of IoT. Of course, IoT is not new. It has been in the it has been there for many years, like 10 years or so. But I remember clearly, like 5-6 years ago, that's when the technology hype started. And I presented this slide 5 years or 6 years ago. So in 2015, I captured this snapshot from actually from McKinsey. It says by 2020, there are 20.4 billion devices connected to the cloud, or we call it the things that connected to the cloud. And it generates $1.4 trillion by 2021 and 11.1 trillion by 2025. And out of sudden, I feel like I'm living in the future because we just went through a terrible 2020 last year. And I started to wonder, like, hey, how many devices are we actually having by now? Or by at least by 2020, did we really have 20.4 billion devices or things connected to the cloud? So last year, end of last year, I did out of curiosity, I Googled a little bit about these statistics. Um, there are numbers here and there, but I couldn't really find exact figure, like whether or not are we really achieving this 24.4 billion things, generating 1.4 trillion US dollar. So I couldn't get a solid information on this. I have no idea why. Probably it is easier to do a prediction than to collect data about the real devices that were connected to the internet last year. Then I started to think like, hey, if we are already living in the future, does it mean we are approaching the end of IoT? Why there are no people talking about IoT predictions anymore? So upon some research, then I realized this interesting uh, sharing from I believe it's from TSMC. So it says IoT is in fact evolved from the IoT that we know in the past. It consists of five elements. So if you dissect any IoT applications, there are these five core elements. First is the things or the sensors, the actuators. Then we talk about the connectivity. It can be a short-range connectivity or long-range connectivity. Short-range, say for example, like Bluetooth, Zigbee, or Thread. Long-range, it could be Ethernet, Wi-Fi. Those are the connectivity. And then the third element, of course, is the gateway that separates, sits in between the short-range connectivity and also the long-range connectivity. And we have the things, we have the connectivity, we have the gateway, and the fourth element is definitely the cloud storage, and the cloud computing. In the past, we talked about storing a lot of data in the cloud. That's when we have discussions like, big data, Hadoop, how do we do data analytics? How do we post-process raw data from sensors or actuators or the things in short, and make sense of these data, and then use this data to develop interesting or useful applications that ease our life. So of course, those are the fourth big data or the cloud is the fourth element, and the fifth element is definitely the application. Like I said, we build useful applications. But if you look at this diagram, definitely big data is still one of the big picture in terms of IoT enabling. 5G is definitely one of it because, like I said, there are five core elements, and connectivity is definitely one of the important elements. And earlier this year, I remember there is this announcement from our government about the 5G enrollment throughout the nation. I'm not too sure what is the progress right now. Looking at the political turbulence and pandemic, I really hope that our country is on track on this 5G. But putting big data and 5G aside, AI is definitely the catalyst to IoT implementation. So in short, AIoT is a combination of AI into IoT. So if you look at this term again, we actually live in the evolution from embedded system. So in the past, we have embedded systems where we connect sensors, peripherals to a microcontroller. And then we use a microcontroller to achieve certain tasks. Like we build a washing machine, we build cleaning robots. Those are the example of embedded system. And when we evolve to IoT, that's when we add in the connectivity elements into existing embedded system. So that is when those are the days where we have a smart fridge, smart TV, smart washing machines. So anything you have, once you have the internet connectivity to the devices, we can simply call it a smart devices, a smart speakers, or you name it. We have been through that, and now on top of this internet enabled embedded system, or in short, the IoT devices, and we add in one more element, which is the AI processing, and therefore we have the AIoT. Now let's take a look at some of the examples. In the past, say for example, in the past we have smart, we have appliances like I mentioned, microwave, washing machines, thermostats, but it evolves even smarter when we apply the AI computing either on-prem or in the cloud. Say for example, in the past we have smart home systems where we connect all the light things, the appliances to the internet, and you can control the smart appliances from your cell phone. But in the past, you still have to turn your light on and off from the application on your cell phone. But try to imagine right now, you don't even have to take up your phone and launch the application just to turn on your light. All you need to do is just to speak to the smart speakers at home, say Alexa, Google Home. Alexa and Google Home basically takes over the control of the appliances, the smart appliances, where they can understand human language. So this part of it is in fact the AI element that sits on top of existing embedded system ecosystem. So of course, to be exact, in this case, it is the natural language processing, NLP, definitely one of the hot topics that we talked about, a few years ago. And then the third element over here is definitely on vision. Like in the past, we have CCTV, we have surveillance camera. We shoot at our entrance, the gate, guardhouse. But now, at a very cheap price, you can even get a surveillance system or a camera, a CCTV camera, IP camera, with the AI processing embedded onto the camera itself. Say, for example, you can buy a camera from Shopee or Lazada at a cheap price. It has this face detection capability where you can store faces of your family, so that the camera can differentiate whether or not there is an intrusion from a strangers or intruders. And also I've seen interesting applications where they build object detection onto a camera, where they use the camera to detect stray dogs, stray cats, or even monkeys. Some of the housing area, they turn on the buzzer, or they play certain sound just to scare the monkeys away. So these are some of the example. Again, it's a very typical embedded system. We have the input, we have the output, but right now, with the AI elements into it, it helps us to achieve even more a useful application. Now, let us zoom into this very typical example. So in the past, when we talk about IoT application, very easily we quote this example, smart agriculture. We place sensors everywhere across the farm. We have temperature sensors, humidity sensors, and then we store all these data in the cloud. And from the cloud, we make a decision whether or not we want to turn on the water pump to water our plants, or we want to, control the shades just to prevent, strong sunlight on our plants. So those are the very classic IoT applications in the past. But take a look at this example. It's a case study from one of these universities in China in collaboration with Huawei. They tried to plant trees in the desert. Remember the 5 core elements. One of it is the cloud, the connectivity to the cloud. But if you look at this video clip right here, it's a desert. Probably there's definitely no 5G signal, maybe no 4G signals as well, and maybe a very, very weak a 3G signal. I don't know. So without 4G, 5G, or 3G, let alone Wi-Fi, definitely there is no Wi-Fi coverage. So in this case, how are we going to achieve these IoT applications? And if, let's say, taking this robot as example, this robot has to maneuver across the desert, and if he wants to maneuver safely, say to do some object avoidance, collision avoidance, stuff like this. Of course, in the past, one of the things we can do is to send the frame back to the cloud, and we do AI processing on the cloud. There are so many APIs, API from Microsoft, API from Google, from Amazon, from Huawei. At a very cheap price, you can, process frames, do object detection at the very short time manner, and then return the result back to the end devices, and then only the robot make a decision based on the result, the AI inference result from the cloud. But if you look at this example, of course, like we said, there is no internet connectivity. So probably sending frames to the cloud for AI processing is a luxury, definitely. So what they did was, instead of sending the frame to the cloud, they pushed the entire AI computing to the edge. So in this case, they put the AI processor on the robot itself. And this robot is able to do AI processing right away on the robot locally. So in this case, probably they may not need to rely or to be too dependent on the cloud. Probably they can do some processing locally and only store important information to the cloud whenever there is an internet connectivity later, or when the robot is back to the base. So this is a good example of how to move or evolve IoT to AIoT with the AI computing. Now let's move on to another classic example. We talk about surveillance. In the past, if we want to do surveillance like this, say for example, I want to monitor the condition of the nursing home or the kindergartens or the elderly care home, probably we need to have of course the classic way, the olden days. In the olden days, we use nurses or teachers, multiple of them, to be with the students or the kids or the elderlies, just to take care of them, maybe 2-to-1 or 1-to-1, that kind of things. But with the advancement of technology in IoT and also AIoT, we can actually use a camera for a lot of monitoring purposes. Say, for example, in this case, we can use a camera plus a very powerful AI processor to do fall detection, or to prevent, say, fighting amongst the students, among the kids. But of course, in this case, we still need to rely on sensors, like for heartbeat detection, or lately we talk a lot about oxygen level detection with an oximeter. So definitely the IoT part is still there, just that with the help of AI processor, we can achieve even more. Instead of placing sensors all around the human body, with a camera, we can, at least analyze the entire situation, whether or not there is a falling or fighting, and so on. Let's move on. Of course, this is another very real live case study. It happens in China. China, they have it's a big area where they have a high voltage transmission lines across the country. So if you look at this data over here, it has 1.6 million kilometer of lines and 4 million transmission towers and poles. Definitely, if you need to do periodic maintenance, it will be a lot of work, especially when we talk about, transmission tower at running at very high power. It is very labor intensive. It is very risky if you want someone to climb up to the tower to do maintenance on these 4 million towers. So what they did was that this utility company, they work with one of the local integration company. Of course, the technology enabler here is again Huawei. They place sensors. In this case, of course, is a camera, plus the AI processor, plus some number of storage and 4G modules for data connectivity. And of course, the entire embedded system is powered by a solar panel plus a rechargeable battery for backup storage. So with this entire system, it helps the maintenance team to achieve even stable monitoring across all the transmission tower. And definitely, with this system, they may not need so many labors, right? And these labors, because of the risk they are carrying, their pay is very, very high. Okay, so what are the things they can do with this monitoring system? Definitely, intrusion detection is one of them. Like, for example, there are cranes across around transmission lines. The system will flag an alarm to the team so that they can, at least warn them not to stay too close to the transmission line. Foreign object detection, of course, mountain fire, missing pins, damper tilting, a loose strand. So these are common examples. And when I talk to one of these local researchers in one of the local universities, I understand that they are helping local utility companies to do similar things, which I am really excited about. I wish to see this kind of technology advancement being implemented in Malaysia. Now, if you wonder what is AI or what is machine learning about, it involves two parts of it. One part, the first part is about training. The second part is about inference. So when we talk about AIoT, we want to run AI on existing embedded system, we are actually talking about the AI inference. So don't confuse yourself. There are two parts. The AI inference is the one on the right-hand side. Say, for example, I use AI to do fall detection. I place it in an elderly care. I place AI processor in on the smart agriculture robot. Those are AI inference, the one on the right-hand side. Definitely, in this case, we'll need the trained model, and I need a very powerful AI processor just to do inference on the AI model. So in this case, I have a new data, say a picture of a cat, and I have a trained model. I train it somewhere else. I bring it over. I store it in the AI processor, and then I fit the AI model with the new picture that I captured. And then after going through the AI trained model, if the accuracy is acceptable, by right, we are able to understand this picture, whether or not there is a cat. Of course, in this case, we are talking about, say, deep learning or CNN to be exact. It draws a bounding box with the coordinate on the picture itself. And those are the inference part. So let us take a quick look on the what happens before AI inference. So before we can actually use this AI on our embedded system, we need to go through a long way, which is on the training part. I take a very simple example. In the past, when we upload photo or we post a photo to our social media like Facebook, in the past, Facebook. Of course, now we have more. We have Snapchat, we have Instagram. Let's just say Facebook in the past. When we upload a photo, we need to manually tag our face. Say I need to draw a bounding box and I tag on Facebook itself. Say, oh wait, this is a face of Eric Lin, and then there's a face from somebody else. So this action is actually called a tagging or a labeling on the data. And Facebook, with all the labeled pictures, they will take a lot of these pictures that they collected from their platform and push it through a machine for the training purposes. So what it does was, with the training data, with the correct label, we are the one working for Facebook, right? So we labeled them correctly. So with this data, they push it to a raw model. It will do prediction, and then this prediction will come up with certain statistic or parameters, say whether or not the prediction is correct or not. And then it will compare with the expected result and calculate the error. And from the error itself, it fine-tunes the model, and it repeats the iteration over and over for millions time until this model achieves certain level of accuracy. So this process definitely is it's also requiring a very powerful AI processor. But in this case, we are talking about the AI training processor. So not to be confused with AI inference processor. So in this case, once the training process achieves certain level of accuracy and we are happy with the accuracy, we can stop the machine and say, hey, let's just stop here. I will use this model as the train model, and then only I move the train model to the embedded system, and I use that to do whatever embedded system applications that I want to design. Okay. Now, since we talk about the inference processor and training processor, there are two big classifications: the training chips and the inference chip. Inference usually it is NPU, GPU embedded with a microcontroller. Say for example, like our phone. Most of our phone nowadays, it is not just an ARM controller, a microcontroller, but it has the GPU, a powerful GPU or NPU embedded on it. Definitely, if you talk about vision application like a CCTV camera, those probably they have certain level of FPGA or ASIC embedded on the embedded system. Whereas on the training chip itself, most of the time we look at a PC, a desktop, or a server with a powerful GPU, like a graphic cards or AI cards, or even in Google they call it Tensor Processing Unit, a TPU. So with this card, it is not really for deployment on field. It is not making sense if you want to slot a very powerful graphic cards on our washing machine, say for example, or we want to slot an expensive graphic card on top of a transmission line, just simply to do AI inference. So that is, of course, in terms of form factor, it is not making sense because a graphic card is definitely bigger. And in terms of power computing, the power consumption, definitely a graphic cards consume more power if you compare to that AI computer or AI embedded system. So quick look on the top here. There are 4 types of chips again. We have the CPU like our Intel, AMD processors. Those are general purpose CPU. It is good at running multiple stuff. You can install many applications like Microsoft. You can use it. Microsoft Office. You can use it to do simulation like MATLAB simulation. You can also use a general purpose CPU to play game or to run some graphic intensive applications like videos, or you do video editings. Those are CPU. And of course, if you talk about graphics, GPU or gaming. So GPU is the important one, where if you compare GPU and CPU, GPU it is very good at running floating point computation. So the application is rather specific. It is not as generic as the CPU. You may not be able to say install game or MATLAB or whatever simulation software on a GPU itself. It needs to have a CPU pair with a GPU in order to run it, so that we can push all the floating point computation only to the GPU, and we leave the rest of the work for CPU. And ASIC, it is an evolution from FPGA. FPGA, again, it's very customized. It is pretty much like a controller, but it's a combination of gates, transistors, where we can code them using, say, Verilog and VHDL code. And then once we are happy with this FPGA, and we can hire someone to fabricate it into application-specific IC. So ASIC, usually it is very application-specific. It can do probably one or two tasks, not as flexible as the CPU, but it can do it in a very, very fast manner, like 10 or 20 times or 100 times faster if you compare to a general purpose controller or a CPU. So these are some of the examples. Now let us take a look at the implementation again in shopping malls. It is a collaboration between Huawei and very big AI giants in China called SenseTime, where they place a CCTV camera, a surveillance camera, at each end of the escalator. So a few things they can do. They can do a baby stroller detection, wheelchair detection. So probably when the control room sees a baby stroller or wheelchair approaching an escalator, they can sound or trigger the security guard to lead these people to a lift nearby. And of course, it can do people recognition at the entrance or the exit for crowd counting, crowd retention, crowd management. Okay, let us look at some of the way. So remember, we talked about two types of AI processor, the training processor and the inference processor. So this is one of the solutions from Huawei. It's a powerful AI computer where you can load the AI model onto this processor and use it for inference. So not to be confused, we are not actually running the training with AI inference processor. So in this case, they probably train it somewhere. They train it in the cloud. They train it with a server plus powerful graphic cards. Once they are happy with the model, they transfer the trained model onto AI inference processor like this, and they use it like a normal embedded system with the integration of sensors and actuators. Let's move on. Yep, another example where they integrate the powerful processor with the camera, and then they link it to the control room, and then the security guard probably sits in the control room to monitor the entire situation across the shopping malls. More examples like not just smart homes, smart agriculture, and we just talk about surveillance in the shopping mall. Definitely, we can actually apply AI in multiple sectors, including existing embedded system applications. So we can see here we have smart cities, transportation, where they use this for toll collections, finance. Definitely, this is AI in the cloud. Electric power, we talked about this earlier on the telco, the retails, e-commerce, and of course the government. Now, I wish to draw attention to one of these local application. This is very local, like it happens in Malaysia, not just in China. We have been talking about the applications in China. So if you like to cook, you are family man, probably you can recognize this brand. Of course, no advertisement. This is a local brand. They produce herbs. So I think they have a factory in somewhere in Klang Valley, Shah Alam or Klang, I cannot remember exactly. So in the past, when they want to produce chili flakes, they hire labor to segregate the good and the bad chilies. And they probably reject the bad chilies and they only grind the good chilies to chili powder. And that is very labor intensive. So again, they work with technology enabler. They implement AI onto their assembly line. Again, it's a good example of embedded system plus connectivity to form IoT plus the AI element to form AIoT. So they use AI inference to separate the bad chilies from the good ones before they proceed with the rest of the production in their factory. Okay, so I'm going to skip this. Now, almost reaching the end of the presentation. So Techmark Group, we are a strategic partner with Huawei. So Huawei definitely is the technology enabler. They have the technology, end-to-end technology in terms of AI from the cloud all the way to training chips, inference chips, and including all the popular one that we are currently using on our smartphone and also our wearables. So Techmark, we partner with Huawei. We supply the technology to the industry, and at the same time, we provide a TTT training as an academy to enable our customers or the lecturers or the researchers or the academicians in the education industry so that the researchers from the institutions, they can take over and they focus on this part, say algorithm research, they incubate ideas, they do talent development, and definitely we can also work with our clients and education or researchers to do some system integration projects. And a short one, just in case you are not familiar with Techmark Group, we have footprints across multiple sectors. The one at top here is the research. We are definitely supplying our solutions to the education customers. We do have our own support team to do calibration and support services. We supply solutions to broadcasting, factories, definitely one of our main forte, the government and aerospace and defense. A quick snapshot of what we are doing. Not only we are providing a product solution, we do training and development, definitely to the industry and also to the education. And of course, we have our calibration and repair team. In short, we call it a Techmark Care team. So with that, I wish to pause and pass the floor back to Miss Anis in case she has any questions.
Okay. Thank you very much, Mr. Eric, for addressing this interesting topic. Yeah. Since we are running out of time, so we are sorry we are unable to proceed with a Q&A session. Okay, we are going to move to the next session.
Sure. So it's my pleasure to be with all of you today. Thank you very much for your time. Bye-bye.
Okay, thank you very much. Okay, bye. All right, ladies and gentlemen, for those who have not scanned the QR code, yeah, please do so now to record your attendance. Yeah? So you can find the QR code on the screen. Okay, now moving along to our next speaker. Okay, for this session, there will be two speakers presenting on the topic. Yeah, for your information, Madam Wincy Chan has been working in the technology industry with tech giants for 20 years and has gained plenty of knowledge regarding cloud solutions that would assist companies in the efficiency of overall work procedures. And on our next speaker, Mr. Tan Chi Weng, he has 70 years of solid experience in wireless platform and product development spanning across tier 1 mobile phones, tablets, and IoT segments. And he is also a very hands-on person and result-oriented engineering professional. Both our speakers will be presenting on fueling industry innovation with Azure IoT and digital twins. Ladies and gentlemen, please welcome Madam Wincy Chan and Mr. Tan Chi Weng.
Hey, hello. Thank you very much for your time. So before we start, let's have a short video to start with.
Okay, Madam Wincy. There is no audio. Yeah, we cannot hear. Can you please turn on the mic, I guess?
Can you hear me? Yeah, I did. Yeah. So you cannot hear?
Okay, we can hear you, but then the slide that you shared just now, we cannot hear any audio.
Oh, when we tested yesterday, it works. Say that again.
Can you share the screen?
Yes, I did. Hold on a second. Let me try again.
Yeah. Okay, can you please share the screen with audio?
With audio, yeah. Share video. Yeah. Yes. I may have missed this one. So sorry.
Okay. Nice.
Yep. Screen share. Okay, let's get started.
All right.
So, let me know if you can see.
Yes. The slide is there.
Okay.
Innovation is a journey without an end, work that's never done. We're constantly pushing the possibilities of our physical and digital worlds that are increasingly converging. Driven forward by technology, from cloud to the edge, AI, and IoT. Now allowing us to create digital models of our physical spaces, called digital twins, creating the stories, touchpoints, and solutions by realizing the relationships and interactions between people, places, and devices. And with the promise of AI, we can uncover insights that see problems before we experience them. We can better understand needs and improve experiences. We can see, learn, and even predict how people move through and interact with the spaces around them. Connecting these stories and data to power modern business, building new possibilities in real time. Made possible by our partners and an end-to-end 3-cloud capability: Azure, Office, Dynamics. Help bring to life smarter spaces that connect to a digital world and turn new possibilities into new realities.
Hey, thank you very much for your time. Let me introduce myself. I'm Wincy Chen. I've been in the business for 20-something years. I've been in IoT since, since it first started in 6 years ago. I'm now the IoT business and partner lead in Asia. My counterpart, Chi Weng Tan, so he's the technical lead in Asia. So today we will give introduction of IoT and digital twins, how it can help the industry in different scenarios. And after the short presentation for the first 15 minutes, Chi Weng will give the live demo. So in the meantime, I may ask you some questions, and feel free to put in the chat for your answer. And at the same time, if you have any comments, please feel free. So Chi Weng is very kind that he stayed in the chat room, and if you have any question, you post it there, and he will be able to answer you. And just to let you know that I cannot see you, and I cannot see myself. I can only see the screen. So if there's anything, please feel free to put it in the chat. Okay, so I assume everyone knows cloud, right? Cloud's been in the market for so long. So right now we've talked about intelligent cloud. So what is intelligent cloud? How intelligent is the cloud? We have the cloud computing. So the cloud computing involving cloud and AI technologies to do all the intelligent stuff. So we call it intelligent cloud. So why we have intelligent edge? So obviously it's intelligent in the edge. So it's the analysis of data and the development of the solution at the site where the data is generated. So it is the intelligent edge. So very quick first question. So why do we need intelligent edge? Feel free, if you have anything in your mind, please post it in the chat and let me know that how much you know about the edge and what do you think about it. So as I mentioned, it is the analysis of data and development of solutions at the edge and the device. So by doing this, that intelligent edge can reduce the latency. Think about what situation you will need very short latency. So it reduces latency, it reduces costs, and also the security risk. And that's it making the associated business more efficient. So very quick one before we move on to the others. Imagine that if you're in a driverless car, smart car, and all of a sudden there's someone, boom, jump up to the road. Then do you think you have that 100 milliseconds, 50 milliseconds to go to cloud and make the decision and come back? No, you need something really quick. So you need the intelligence on the edge to make a quick decision. So that's the reason why right now we have cloud, and at the same time we have edge. So we have intelligent edge, intelligent cloud to do a lot of modeling from the cloud side. We will need more power to do a lot of new modeling. And with the IoT, with the edge computing, with the AI that you should have heard from previous section as well, digital twins, we build a lot of connected solutions. So we are going towards the connected environment. So we have the IoT, we talk about the connection of assets, different devices. And then right now we are emerging to the connected environments. And in the very near future, we have the connected ecosystem. Everything built together, everything's connected together and affecting each other. So connecting environments, we talk about different industries, different scenarios. Please, while I'm presenting, feel free to think about what scenario or what industries benefit from all these connecting solutions. We already have some on the screen, and think about something that you think it may help. And feel free, put it in the chat. Chiweng will be replying you instantly. And just share with each other what you think about the overall IoT digital twins. So we talk about connected environments and how can we make use of the IoT data from different environment and scenarios. You can think of IoT can actually apply to every industries, every scenario. So for example, very typical manufacturing. Manufacturing, you see here, plants, factories, industrial sites, utilities. It's kind of like a very early adopter of IoT because they need the data to give insight how to do more predictive maintenance and save costs and do less unscheduled downtime. So imagine that in the older days that in manufacturing that we are very much based on some our factory managers' experience or some experience of workers that they tell you, oh, this production line may have problems, so we will need to reboot it. We need to fix it. It may have problems soon. Why? By my experience. So now we have the IoT to collect all the concrete data, and it's not only by the experience, it also may collect some data related to what's causing the problem. Would it be only the heat of the production line causing the problem? Or maybe the production line is shaking? Or it's caused by other production line nearby that to cause this one has problem as well. So these everything have some pattern. We base pattern to do more prediction and do more accurate prediction. And at the same time, we'll keep fine-tuning what we learned and make more and more accurate prediction. So this is a very typical IoT scenario. Or we talk about retail, how to save cost, how to get better customer experience. So imagine that if there's you can see that here, stores, warehouse, how to keep the minimum, the optimal stock to make sure that we have enough stock, we will not overstock, but at the same time, the customer, they're happy that whenever they need it, then they will get it from your side. So it's also from the retailer and also from the customers. And other than that, then how about if you imagine you are the VIP of a luxury store? You buy a lot from this luxury store, and if I go to another one, if they can use some IoT, AI, video recognition, facial recognition, checking. Once you step in the store, they already know that what you like, what's your purchase experience, and then it will be so cool. And at the same time, that if you can imagine that if you have picked up some product in the store several times, then you are already very interested in that product. So what if our salesperson approach you to introduce more of that product? It will also increase the rate of selling. So all these can help a lot from the technology of IoT and AI. And also like building, I think right now the hottest topic after the pandemic, how to ensure the social distancing. If the people maybe they're getting too close, we can give alert to the people or to the store that to remind them not to stand too close, or if they are wearing masks. Right now, there's a lot of requests to check if there's any application that can detect if people is not wearing a mask. So some of them are very very simple that you can think of. They are already using the IoT AI scenario. And also with the also digital twins technology. So imagine, for example, like the Twin Towers in KL. So very high floor, and maybe there are several floors and more busy. So imagine that how busy is the different elevators in the building. How can it be more optimal to put the elevator in which floor? It definitely can save a lot of maintenance costs of the elevator, and also increase the satisfaction level if the elevator is always available, is not malfunction. And also at the same time that like campuses or offices, how to make use of all this. So for example, I think in the campus, in the university campus, it's very typical. Hey, there's meeting rooms, there's seats available, but maybe there's a lot of empty rooms there. But here is always not enough rooms. So how to produce, how to optimize the number of meeting rooms in which areas, how to collect all these data, which areas are more busy, which rooms is more occupied, etc. So we talk about IoT. It's been in the market for several years. You all know that IoT means the assets can connect to internet to collect data. So what is digital twins? We have talked about the digital twins maybe this couple years more often. So digital twins is a digital replica of the real world things, places, business processes, and people. If we talk about like all about the whole set of real-time data, replicate to another set of data, and then we can do some live simulation. We can use all the real data to do simulation. Since we have all the engineers, lecturers, you're all here, you should know that how complicated to build a set of simulated data for your model. So now with digital twins, we can use all the live real data to do the simulation. Even I can use the example I just talked about in the Twin Towers, in some very high tall buildings. So how will it affect the elevator? You use the real-time data like in the peak time, people going to office or leaving, or even worse, that evacuation. If there's fire, evacuation, what is the best way to evacuate all the people from the building? Or not that critical, not talking about the fire in the building. So let's say in the stadium, if there's a concert or it's a ball game, that's a lot of people. If the game is ending, a lot of people stuck in different exits. How to do all this kind of a simulation, how to direct the people to different exit will be better. Instead of just looking at it, it's monitoring, using the digital twins, that it can use the live data to perform, to give more insight and forecast of what can happen. So as well as the physical assets, the digital twin technology can be used to replicate processes in order to collect data and predict how they will perform. So you can see from the picture, it's like all the data here and replicate the otherwise very, very visualize digital twins concept. So using digital twins, using the real world data, it simply simplifies the whole creation of a comprehensive digital models. So it's like a computer program that can track all the past data and simulate the possibilities and help predict the future of any connected environment. So it's a robust platform for building enterprise-grade IoT connected solutions with the scale, compliance, security, and privacy that benefits customers to bet their business on. So before we go to the live demo, there's maybe a field experience to share. So this one is from a company called Ansys. So it's a physics-based simulation. So Ansys uses IoT and digital twins to enhance the product design. So you can imagine that while you are doing all the engineering, the product designing, and then it can help the engineers to optimize and validate their design choices. So if there's anything changes, what will happen to this? And then you can quickly change through the digital twins. And using digital twins to analyze the current product behavior and also forecast the impact of the changes in real life scenario. We can quickly apply what you change the product using the real-time data and change it, and then apply another set of real life scenario to it and see what will happen. So they use digital twins to monitor and optimize the process for the whole designing lifetime. So another one, GE Aviation. So for the flight, so they use the digital twins to create a living replica of an aircraft. So they have two systems. So one system is to keep track of the performance of an aircraft when it is in the air. So the other system keep track of everything that happens to an aircraft once it lands on the ground. So with the new system, that the GE Aviation will have a living database to track the performance of an aircraft. It helps gain insight to predict issues and suggest actions to remediate issues and ultimately decrease the cost of maintaining the aircraft. So you can also imagine that how aviation to make use of IoT and digital twins. One of another example is also for aircraft is from Rolls-Royce. That Rolls-Royce making all the engine for the aircraft. So they use all those IoT data and then to see how the aircraft using the engine on the flight and how much gas they are using. So that's how they can plan for maybe the better use of the speed of the flight, the route, and everything, so as to save the cost of the gas. You cannot imagine how much cost of the gas it can save. It can save like millions per year after they deploy the IoT. I'm not going through too many examples because we have too much to talk about. So last but not least is Smart Spaces, is Microsoft Campus, our headquarters. So we have a lot of buildings in our headquarters. We build on the digital twins, which has more than 200 models. So it processes thousands of sensors per building in real time. So it supports the next generation of experience, like how to find and reserve a workspace, how to navigate between each buildings, and also some like COVID response. If someone's been sitting on that table for too long, or someone just left the desk, then we'll dispatch the cleaner to clean the table to make sure everything's clean. So there's anything it can help, like very big or can be very small, and it all leverage the IoT and digital twins. Before we move on to the live demo section, and also Chi-Wang will talk more about some devices. A very quick video that this like summarize a lot of scenarios from IoT and digital twins. Thank you very much, and we'll pass to Chi-Wang after this video.
The term smart building gets thrown around a lot, but at its core, a smart building is a structure that enables sustainable communities, improves occupant experience, and reduces operating costs. But what makes a smart building smart? It's the robust backbone of data that's compiled throughout the building lifecycle that makes all of this possible. Enter the digital twin. Quite simply, a digital twin is a virtual replica of a physical asset. It collects and organizes data from a variety of inputs to derive insights that optimize asset performance and user experience. First used by NASA to assist in space exploration, the digital twin has found value in other industries: manufacturing, health, automotive, and now this powerful tool has come to the built world. From the very beginning of design, through construction, to the transition of sustainable occupancy, information is gathered and funneled into a digital copy of your building, giving you the ability to see what's ahead and know what to do about it. Quite simply, if you better understand what's going on with your building, you'll better understand your investment, increasing occupant satisfaction and building performance. Together with this powerful tool, we can build more connected and sustainable buildings that give you insights into your asset like never before. This is the era of smart buildings. This is the era of the term smart building.
Hey, thank you very much. So we will give the stage to Chi Wang.
Okay. Madam Tan, Mr. Tan. Hello, Mr. Tan. Okay, we cannot hear you. We still cannot hear you. Still no audio. We cannot hear you. Okay, no, still no audio. Okay. Hello, Mr. Tan. Oh, no. Still cannot.
How about now? Can you hear me?
Okay, yes. Good.
So sorry, some technical
Alright.
issues about that.
Okay,
So
the first.
yeah, everything is good. So yeah, let us start. So I'm Chi Weng. So I'm the senior technical specialist from the GPS team, the global partner solution team. So today, before we go into the live demo, I would like to talk a bit on the, Microsoft have a very wide variety of broad portfolio in terms of devices as well, right? Not just from the cloud side. So today, as we know that the compute power form factor gets smaller, faster, and more reliable, we have all the devices, with the possibilities of various type of workload at the edge side. And I hear the previous speaker talk about AI ML workload on the edge. Actually is no stranger, and from Microsoft perspective, it enables the edge from silicon from the tiniest sensors that runs on the MCUs to the active endpoints and even gateways to large appliances, to enable all these devices to be able to connect back to the Azure cloud so that, you can get all your harvest, all your data, on the cloud side. And today, what I'm going to introduce here is something pretty interesting that Microsoft actually created, and that is our Azure Percept Dev Kit, which actually helped to, which we designed to specifically to include everything that you need to get started easily, that empowers you to develop and run intelligent edge type of workload. So what you get out of the Percept Dev Kit, right, is the main CPU, which is the Edge Gateway, and a camera module that actually is driven by a VPU here. On top of that, there's also a Percept Audio module that comes with a microphone array for audio-related AI workload, for example, like speech recognition and so on and so forth. So first of all, the device, as Azure certified hardware, it integrates seamlessly with our Azure AI services as well as the IoT services, for example, like the IoT Edge services that actually runs on the gateway itself to help you to manage and make it like a hybrid mode type. And the device actually connects back to our IoT hub and also allows you to use other services. So it includes it also includes AI models, pre-built AI models that bundle with the Percept Studio, which is actually a collection of Azure services that help you to easily provision, deploy, and manage AI solution at the edge, right from the cloud side, right? So imagine that remote management from the cloud, make it easy and seamless. So Percept actually work out of the box, and it actually integrates also with our cognitive services, machine learning services, as well as the live video analytics. And nonetheless, other Azure services that you can actually deliver vision and audio insights, be it real time or offline. Okay, so the overall objective here is actually to simplify the edge and also the AI workload to help developer, that we know that there's still challenges when it comes to deploying IoT technology. So today, in a typical IoT engagement, it requires long lead time, which is about, average about 800 days before a scale deployment. So with IoT and Edge actually comes into the picture, this whole process actually gets longer and even more complex. So where we come in and help to simplify is by creating an Edge AI. So for example, here, like the Percept Dev Kit, you can actually use it and by providing the entire platform and also a reference architecture for you or as a developers, be it skill, any skill levels, can use the pre-built models to go and prototype and use it as a a way to do POC as well as production in an accelerated manner. So advanced developers can also use to customize their own models, retrain, do transfer learning, do much more advanced workload and apps in just days. So this kind of workload would help. Actually we have taken hundreds of thousands of dollars through months of works and highly trained specialists, but we're trying to simplify the entire process flow here. So the new approach actually helps you to shorten the development time for sure, lower the time to market, and lower the complexity to operate, and also increase the opportunity to differentiate as well as monetizing your end solutions. So besides Azure Percept, we do have a wide selections of OEM partners that's working in to provide IoT Edge as well as AI-specific devices to help to accelerate the POC from POC to production. Okay, then the next, as the Azure Percept is built leveraging heavily on the Azure IoT Edge services. So today I would also like to start, before we start the live demo sessions, I would like to introduce you to the Azure IoT Edge service. So what is Azure IoT Edge service? It's actually our fully managed service built on the Azure IoT Hub, which is based on cloud. It allows developers to deploy cloud workloads. One second. Yeah, it helps you to deploy cloud workload, right? Like the AI or any of the Azure services right? As well as third-party services or running your own business logic via standard containers. So you can use to offload AI and analytics workloads directly to the edge side rather than sending your workload back to the cloud to do all these things. So in this case, you can leverage existing developer skill sets and code and to reduce the IoT solution costs over here. Azure IoT Edge is actually made up of 3 components. The first components here is actually the Edge modules, right? They are executable packages implemented as containers that runs Azure services, third-party services, or even your own custom codes. They are fully managed and deployed from the cloud side right to the edge and actually execute locally on the edge devices. So the edge modules actually implemented as Docker compatible containers. So multiple modules can be configured to communicate within each others to create pipeline of data processing or complex workload. You can expect, you can also develop custom modules or package certain Azure services, which we offer as containerized edge versions into modules to provide even offline insights at the edge side. Then next, we have the runtimes, the IoT Edge runtime services that helps you that runs actually on the IoT Edge devices, which enable, manage, and even deploy custom or cloud modules on each of these edge devices on the field. Lastly, the cloud-based interface that enables you to remotely monitor and manage all your edge devices and the module twins to work seamlessly with our IoT Hub here. So how all this works and operationalize in a few simple word, you can actually create multiple modules that resides on a Docker container itself. Then you actually upload the modules to a container registry for storage, which actually residing on the cloud side. So the next thing is you actually create a deployment manifest, which basically is just a JSON document that describes which modules to deploy, how the data flow between the modules, and the desired properties of the module twins. Then you can submit the new deployment to the IoT Edge. So the deployment will not be pushed to the device first. Instead, the device actually query the IoT Hub regularly if there's any new instructions or any updates. Then the device find an updated deployment manifest. It actually uses the information about the new deployment or the updated deployment to pull the modules down from the module image down from the cloud and start running these modules locally. So you can have imagine fully managed services from the cloud side to the edge. So without going down to the sites to do updates and things like that. So everything would be done from the cloud end. So there is also many Azure services that you can deploy as an IoT Edge modules, right? From our cognitive services to machine learning to analytics to functions, storage, events and stuff like that. But not just that. There's also a lot of third-party IoT Edge modules that our partners develop and they are readily available in the Azure marketplace. So that's all. I want to do a quick introduction about our Azure IoT Edge services. So next is live demo. So let me unshare this and I will share another desktop over here. Just bear with me for a moment. So okay, so so just now I talked about the Percept Studio, right? With the Percept Dev Kit. So it's actually part of the Azure portal. So the Percept Studio actually comes together with the Percept Dev Kit. So and it's from the cloud side. So this is the overview page. So for example, now I have my device, sitting at my desk right now. So you can see from the cloud side, this device over here, EasyPercept BCF, is actually connected to my IoT Hub that actually I created over here under this specific resource group. So if I go into the Percept DevCube, this is actually I'm assessing my hardware right now. So you can actually look at your device from the IoT Hub, where you can actually look at all the modules that you actually deployed from the cloud side and manage the module twins identity. So 1 second, let it load. Yep. Right now you can see that these are some of the modules that are running. So you can look at the status, what are the modules that are actually running on it. So by default, the de facto, the Edge agent and the Edge hub is a default module that will be running. So I have other modules that actually controlling the camera, the Azure Eye module, the video analytics on the Edge side, and so on and so forth, and also web stream for my RTSP streams later on for the video. So you can actually, look at the properties, the desired properties, and also the configurations of the module twins from the cloud side. So you can actually configure right on the fly how you want the environment variables to be, and things like that. And over here, if I go back to this, there is also a vision tab and also a speech tab. So today we're going to focus on the vision side. So over here, there is a few actions that you can actually being provided from the Percept Studio. So for example, you can actually, view your data stream. So you can see this is actually what being positioned from the camera to my dining table. So I've just put a few objects here. So they are actually doing a live inferencing over here, a simple one. Then there is pre-built sample models from general object detections to people detections, product on the shelf, or vehicle detection. So these are some of the pre-built common models that you actually can deploy right away from the cloud side. So just in my current Edge Percept, I have the general object detection deployed. So I would like to show you that how easy it is, right? I'm just putting it as a vehicle detection. What you do is you select and then you just do a deploy to device, right? So what you do here from the status, you can see that the model has been deployed successfully. And if I go back to my video stream here, the model has already been sent down from the cloud to the edge, and you can see here it's loading the model. So what you can see here is all the the other object detection will be removed, and they will just able to detect the toy car here over here. So just give it a couple more seconds, so you can see that this is a van and this is a car. So okay, this will be the vehicle detection model. So allow me to go to another thing. So this, you can also train your own custom vision, create your own custom vision project, and actually deploy your own custom model, right? Or pre-train other models from your end. So all these things you can actually streamline using the Azure DevOps, having a seamless continuous integration and continuous deployment, directly from the DevOps down to the edge side. So if I go back to how do we create an AI project, right? So it's pretty simple here. So the AI project, since that the dev kit comes with vision and speech, so over here you can actually add your own custom vision project, create the name, give a description. So whether you want to do object detection or image classifications, right? And then select your optimizations. So I'm not going to go through the creation here, but simply if I go back to existing project that I've just created. So this, the Percept Studio also automates data collection. So for example, if you want to collect image for model retraining, or and also optimizations and creating a new model. So what you can do is you can actually even mount your device in the field and actually control your device for image capture, right in front, at the convenience from your home or in this portal. So what you do is, so I will just select which IoT hub that actually the Percept device actually registered. So I can see that I currently have one Percept device being authenticated and connected to my IoT Hub. So what I can do here is I click on the automatic image capture. So for example, I want to do like 1 frames for every 10 seconds, and I want to capture like 5 frames, let's say, for example, here, right? Whether I want to set up for retraining or even a new model training, right? So what I will do here is I'll just click on the set automatic capture, and actually you can see from the progress bar, a job will be actually sent out to the edge side, you know, to do automatic capture over here. Then later on, you can actually use our cognitive service, which actually integrate with the Percept Studio to do image tagging as well as model training. So if you go into the project that I've just created, actually it will just automatically create the project inside the custom vision of our cognitive service as well. So if I go into here, the cognitive service, so you can see that so some of the tag of my photos that I've taken. So the new photos will be marked as untagged. So what you can do is you can actually open it, right, and then you can actually tag it with the tags that you actually name. So in this case, like Savan, so and so forth. So for example, like this. So once you have tagged it, right? So you can actually train your model, right? Whether it's a quick training or it's an advanced version, right? So what you actually want to perform, you can actually, set your configuration here. And then not just that, but also the performance of the trained model. So you can have different iterative, by collecting more data at different angle, different light sources, right? Different types of objects. Then from there, you can actually improve your model. And from here, you can actually tell, the performance of your trained models and also the tweaking of the performance over here. And there's also a way for you to do prediction. Test your model. So you can actually load, do a quick test, load an image, and then see how accurate the model is, right? So once all this is done, I mean, I'm not going to go through the training because it may take some time here to do the training. So jumping back to the Percept Studio, right? After you have trained your model, you can actually evaluate, right? The trained model here. Right, and then just now, this morning actually, I did another training, which is iteration 4. So you can actually use the Percept Studio to deploy and test your model, or of your trained model here. Right, if I deploy the model, so it's just by easily clicking a button, right, and just deploy your trained model based on the cognitive service. But of course, for advanced workload, you can also use our more advanced service like the Azure AI MLs to do much more rigorous and complex model creations and training, and then use that to seamless and make use of the Percept and also our IoT Edge service to seamlessly deploy and manage, your AI workload from the cloud side. So coming back to this, so I think it's pretty much on for the demo today. So what you can see, from the one more thing that I want to show you, besides having the RTSP, right? I think the inference data, you can also view all your inference data, right, from the IoT Hub. So from here, you can actually look at the live telemetry that is coming in from the inferencing results. So besides just the image, right, but because usually you don't send the image back to cloud, but just the results itself. So for example, here like a potted flower, and then showing the telemetry data of the bounding box, and then what is the confidence level, the timestamp. So imagine that with some of these live streaming telemetry that is coming into the IoT Hub, you can actually store the data, publish it in a dashboard, or even do further queries and things like that, And even if, let's say, there is a alert, right, using the Azure functions or Stream Analytics to do further processing of your data, and then you can actually trigger the notifications, or things like that. So, can imagine how you combine a hybrid workload of like an edge, as well as the limitless compute power of the cloud, right, to create a hybrid solutions like this, which actually will give you a lot of you're able to address different industries like what Vinci have mentioned. So even people who are not very well versed into the AI, you can make use of these PaaS services, right, to create your solutions, or your business value and things like that, and do a quick POC out of it, right? So I think that's all for me for this sharing session and demo session. I'll pass it back to Miss Anis. Thank you very much for
Okay.
the time.
All right. Thank you, Madam Vinci. Thank you, Mr. Tan, for that excellent presentation. Okay. So I'm afraid that we don't have much time for Q&A session. Yeah. So all the questions will be forwarded to you through email later on. Okay.
Yep. Thank you, everyone.
So thank you to all our speakers today, and thank you for attending this session. So you are invited to join the next parallel session after this. Hope to see you again, and please enjoy the rest of the summit.
Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. Ladies and gentlemen, welcome to another session of I2ES 2021 Parallel Session. My name is Nur Azwani binti Zakaria and I will be the moderator for this session. In this parallel session, we have two excellent speakers to deliver their presentations. Without further ado, I would like to introduce you to the first speaker. Our first speaker for this session is Professor Dr. Rosalina Abdul Salam. She is the Dean of Faculty of Science and Technology from Islamic Science University of Malaysia. A little bit on the speaker's background. Professor Rosalina obtained her PhD in computer science in 2001. She has a vast experience in academic and impressive numbers of high-impact publications. Her research interests includes image processing, artificial intelligence, AI, and speech processing. The title for Professor Rosalina's speech today is Artificial Intelligence and its Impact on Jobs and Workplaces. Without further delay, please welcome Professor Dr. Rosalina. Professor, the floor is yours.
Okay, can you hear me? Assalamualaikum. Can you hear me, Dalila?
Yes, Professor,
Can
we can
you
hear you.
hear?
Loud and
Okay.
clear.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And thank you very much for the introduction, Dalila. Okay, I'm really grateful today that been invited by Miji to give this talk. And actually, I'm sure that all the participants has heard the earlier two speakers from TechMark and also Microsoft. Okay, so that's a very interesting talk that been given by them on the application side. And just now the video also showed some of the applications that been developed by using AI. So let's start my talk here. Can you see my screen now? Can you see the screen?
We cannot screen you. We cannot see your screen yet. Your slide is not shared.
Oh, I already shared. Okay, I stopped sharing first.
Maybe
Then
we'll
I
take
share
a
again.
bit of time.
Okay, hold a second. I start to
Alright.
share it again.
No problem, Prof. Take your time.
Okay, thank you.
Alright.
So, yeah, I think I'm having some problem here for a second.
No problem, Doctor. While waiting for Professor Rosalina to share her slides, I would like to remind all the participants to scan the QR code for your attendance today. Okay, Prof?
Okay, wait. It's still not because I go to the window, but it's not working. Wait. Hold a second. I'm so sorry about this. Just now it was already shared. Okay, share screen. Again. Okay.
Maybe you need to share your entire screen.
Yeah. Okay. Now, can you see
Let's try
that
that.
now? Okay, can you see now?
Yes,
Is it
Doctor.
there?
Yes,
Okay.
very clear. Thank you very
Okay.
much, Professor.
Okay, sorry for the delay to all our participants. Okay, so yeah, okay, so this talk is going to be quite a mild one compared to the earlier talk that you have heard. Okay, so what we're going to go through today is just to give some brief introductions about this impact on jobs and workplace when we talk about artificial intelligence. Okay, so let's start with this. Okay, I'm sure that each of us have heard about industrial revolution, and recently everybody been talking about the fourth IR.
Hello, Professor. We cannot hear your voice. Professor, are you still with us? Professor Rosalina? Okay, maybe we have some technical issue on Professor Rosalina's side. Let's wait for Professor Rosalina to come again on the platform. Welcome back to the parallel session. Okay, we are sorry for the
I'm sorry,
interruption,
yeah.
Professor.
Okay.
Sorry. Okay, Professor, you can continue with your presentation. Thank you.
Okay, so can you see the slide now?
It's still not showing.
It's
Maybe
still
you
not
can. Yes.
showing.
Okay. Now it is showing. All right. The floor is
It's
yours.
showing, right?
Thank you.
Okay, I'm so sorry for the technical issues. Okay, so I don't know where I was just now. Actually, I'm starting. Uh, hello, Janava. Okay, I'm starting back my presentation. Can you hear me?
Yes. We can hear you, Prof.
Okay, sorry. Okay. So
No
okay,
problem.
okay. This is about the okay. I'm starting about okay. Our talk today is about this impact of AI on jobs. Okay, so let's look at the first industrial revolution, which is in 1760. Okay, so when we look at that, we started with simple steam engines, water, steam power, okay, and textile industry. So then in 1900, the second industrial revolution, we have technological advancement a bit on the electrification, engines, turbines, and others. Okay. For your information, actually, artificial intelligence started during 1950s. So it's actually nothing new. To us, it's not a new when people in the background, actually in artificial intelligence, this is totally not a new thing, even though when we talk about this fourth industrial revolution. So it started around 1950, and robots is actually our first robot is around 1939, which is called Electro. Okay, so then in 1970s is our third industrial revolution, whereby we have we get more about into computers, okay, internets, and then we have robotics, IT, and operational technology. So basically, for all of the industrial revolution, there will be a lot of job losses. Okay. And then these are quite scary when people talk about every time when we look at industrial revolution. So some people might be a bit worried and a bit concerned about our jobs. Okay. So, but bear in mind, through history, throughout these three industrial revolutions, actually, even though there are job losses, massive job losses, but new jobs being created. So if we look at maybe at the first industrial revolution, is quite labor intensive. But when we come to the third industrial revolution, where we have computers, robotics, so that labor becoming less, but there are more jobs in the innovation and the designing part. Okay, then now today, we are already in the fourth IR, fourth industrial revolution. So if we look at this, it's a big or it's a huge change. Okay, compared to the other three industrial revolutions, the fourth industrial revolutions involve with higher scale and higher complexity. Okay, let's look at the next slide here. Why I'm saying that? Because if we look at this chart, okay, from a Legacy Research Group, we can see the growth in technology. So during this era, okay, in above 2000, year 2000, you can see that the increase is exponentially in technology. Why? Because as I said earlier, actually, even in 1950s, AI is already there. And I mean, it moves quite slowly. And at that particular moment, it was just on the research part. Okay, to be honest with you, when I completed my degree in 1982, and then I started my master's in Sheffield at that particular time, one of my research is already in autonomous mobile robot. So we have used reinforcement learning. So those are early 1990s, okay, but that is under the lab experiments. So now we are seeing that all the things that has been done earlier from 1980s, 1990s, 2000, and now we are actually enjoying those research has come up to reality. So we are experiencing, and then we can use all this technology that has went through the research earlier. Okay, so but when we look at this, when a bit like when people are talking about the concern about job losses, especially for the fourth industrial revolution, obviously there will be job losses because of these technology advancements that are happening. So you can see that how this exponential. So you see all the cell phones, okay, and now that earlier around 1990s, like not even every house got telephones, but now almost everyone got a handphone in their pocket. Okay, so then next, okay, before we go any further, just to a brief introduction is about AI itself. It might not be something new to you, but just to overview, okay, maybe some of the participants might not really know about it, but nothing new. Okay, AI is designed to learn and self-improve. And as mentioned earlier, it's been started in 1950s already. So, but it's a very powerful tool. I think you have seen just now with the video that have been shared earlier. What kind of applications that been happening currently with AI. Okay, so now we are, and just bear in mind, the AI is nothing new. It's together with us already. It's in with us in our daily or everyday routine. Okay, so let's look at the AI applications. So we can start from as simple as gaming, and then we have astronomy, healthcare, transport, agriculture, education. So obviously we are now with the pandemic, a lot of things that we're using in education, online education. And then we have e-commerce, shopping now. Everybody is like having a personalized shopping. And then we have entertainment. We do have robotics, automotive, and then social media, data security, and also finance. Okay, so basically, is there any area that surrounding us at the moment without AI? So this is something that you can just sit down and look around at everything, even your smart TV now, your smartphone, okay? And if you are playing games, there's something AI in there. If you are going through online learning also, we are using partially we are already using AI. So basically it's everywhere. So let's look at, in order to make our life easier, to use the machines, the interfaces, again, the interfaces are also linked with AI. So look at this thing that when we are operating our robot, okay, even with our cars, in our car, at the hospital, the medical equipments, even the buses and railways, your flight, aviation, and obviously military and aerospace. So we cannot run away from it already. And we know that I think just now Microsoft also shows some of the tools or software that are available. So it will help us with the interfaces. So about the AI application just now, other than the normal daily life, we also have other robots or machines that been invented. As simple as we have Sophia. Now here is a robot. Actually, Sophia is a social robot, humanoid robot. And for this year, they are preparing for mass production, meaning that soon, like our handphone last time, is quite expensive. But along the way, or to a certain extent, now it's like everybody can own it. So this is going to happen also with a social robot or humanoid robot. So we have Sophia with already with a citizenship. And then at Harvard University, they have this tiny RoboBee, okay? And this tiny RoboBee, imagine that if there's a little nano cameras there, it can just like act as it's actually acting as a small drone. It's just like a very, very small, if you look at the 1 cent coin there, and putting that, this tiny RoboBee beside the coin, you can see how small it is. So it can fly everywhere and can start to take pictures. So that are the advancements that we can see soon. And what we are talking today is about jobs in 20 years from now. So, okay. So what's going to happen to us? Okay. And then also for hiring also we already have tools, okay, to screen out our CVs and to check our communication and social media and whatnot. Okay. Then for the medical, we have this quite a great Da Vinci robot. Some of the big hospitals are already having it. And then we have for agriculture, we also have, this is one example of MIT robot gardener. So the one that I'm showing you here this last photos is actually a human and the robot picture, because we cannot run away from working together side by side. So these are more examples about how robotic surgery is helping patients and doctors. So imagine with all these equipments, of course, our quality of life will be improved. Our living standards will be increased as well. So, however, when we have more equipments, meaning that there will be less people involved in certain areas. So look at even army here, the US military will have more robots than humans by 2025. So meaning that even armies will get less, but it's not saying that it was going to be obsolete. There will be still armies, there will be still medical doctors, but it'll be replaced with a lot of machines. Imagine, as I said, that we started in 2000 and now it's 2020. So what's going to happen another 20 years from now? Because this is what we are already seeing currently. So then we also have these agriculture robots, okay, helping. Again, of course, the labor intensive in agriculture will also be tremendously reduced. Okay, one simple example is actually a Nam Hong restaurant, okay, in Ipoh, already having their own robot waitresses to take orders. So this is actually in Malaysia. So it's not nothing new, even we are in Malaysia, right? And I think they have another branch in Damansara, if I'm not mistaken. Maybe some of you went to this restaurant already. Okay, let me have this. Okay, this is a word from Bernard Ma. He's actually a strategic business technology advisor. So what he said is computers and automation will come together. So in an entirely new way, with robotics connected remotely to computer system equipped with machine learning algorithms that can learn and control the robotics with very little input from human operators. So meaning that we are no longer needing more people, okay, to do the interactions because it can be simplified. Okay, so and computers and automation will come together, same as when it goes to human. Okay, and then co-leader of the World Economic Forum's Center for the Fourth IR, Zika Reiger. Okay, and he said that as AI begins to impact the workforce and automation, replaces some existing skills. So we are seeing an increased need for emotional intelligence, creativity, and critical thinking. So what it's saying here is actually jobs will be reduced, I mean, in some areas, and some will be obsolete totally. But there are new opportunities and will be more new jobs coming in. So, in fact, when we talk about balance, the numbers of jobs will be even increase instead of decreasing. But some, older versions or older kind of working environment will be obsolete, or they will be still be there, but in a less numbers of staffs. Okay. So this is what I think the major concern, and people been talking about what's going to happen, but we see that we're already in the fourth IR and things are moving. So, and then we have Mark Benioff, okay, Salesforce chairman and CEO. So what he's saying is every business leader can have a direct role in creating economic opportunity for millions of people by investing in education and training programs. So what we are talking here is actually about investing in education and training programs. So meaning that the earlier graph shows that it's going to be exponential. So then the training and reskilling and also retraining need to happen quickly. And at the university, the programs that we offer also need to be some changes soon, okay? We have to already pick it up now, okay? And then this is actually for existing and potential talent. So we can't wait that long because otherwise we won't be able to cope, and how these people, the graduates, are going to get the jobs. So that's a major concern. So those are jobs for graduates, but also those that we are already working now also will be affected. So meaning that we keep on have to enhance our skills. Okay, skills machines and AI cannot perform. Okay, we know that we talk about what AI is going to be and how robots is going to take up the world, but we know that robots to a certain extent. After all, robots is what we created and is what we put into the robots ourselves. Okay, so then what's the thing that we need to look at our skills? The first thing is about higher cognitive skills, and then transdisciplinary. So currently, even though you are engineers, okay, being in the engineering area, so you should also involve with the software, meaning that the artificial intelligence, especially on the software skills, need to be there. So workforce basically need to have reskilling and retraining. Okay, and then for higher cognitive skills, we can look at what actually these machines and even AI to certain extent cannot govern this. Okay, meaning that we human beings still have these skills that can remain with us, but we have to brush up our skills. Okay, it's about advanced literacy and writing. Of course, we do have Microsoft, we do have other software tools that helping with the writing, but only to a certain extent. There are still people needed in this kind of work. And then we have to have the social and emotional skills, because robots, of course, robots that we are creating will also have emotional, like Sophia. Okay, she can blink her eyes, okay, and she can also smile. But not, again, it's to a certain extent. And then the negotiation skills, okay. Even though AI evolves, okay, it evolves meaning that it can retrain by itself, but those negotiation skills is actually embedded with us from the beginning, so we still have that power, okay, and obviously critical thinking. And another thing is communication skills. Whatever that robots has, again, when we have a better communication skills, it still can overrule some part of the existing or the new robots that coming into place. And then quantitative and statistical skill. So these are all the skills that we have to enhance, and bear in mind that it can be almost all. If you have, then this is going to remain you in the workforce. Okay, and then complex information processing, ability to manage others. Okay, robots is kind of like still a system basically, even though it's intelligent. So ability to manage others, like the CEO job, still remain. Advanced technological skills, okay, because it keeps on evolving. So whatever evolving, we still have to embed it into again with our robot, even though we know it can evolve. Okay, then the data analysis and finally engineering is still there, but maybe lesser numbers of people are required. Okay, so this is from the website actually, about 15 jobs that will be replaceable and 15 jobs that will be non-replaceable. So look at this, okay. So if you look at this, why we are saying that accountants can be replaceable? I mean, not all, but to certain extents, we don't really need that many accountants anymore, because the spreadsheets, the software tools that will be available soon, we can have lesser accountants, lesser number of accountants, and advertising sales people, benefits manager, couriers, delivery people. Now we see that we have Lalamu, we have Grab. Okay, soon, what I'm saying is about in 20 years, okay, in 2 decades, okay, and then the customer services executives, because some basic simple questions can be answered by them, by the machines as well. So then obviously data entry and bookkeeping clerical been reduced quite tremendously already, even in the third industrial revolution. Doctors. Okay, this is interesting because we know that people get sick. I mean, this is normal. But as machines coming in, as equipments coming in, so we don't need that many doctors. It's not that we don't need doctors at all, but we still need doctors, but to a lesser, same like accountants just now. And market research analysts also, because obviously AI can do that market research analysis. Proofreaders, automated software can do this. Receptionists, again, we can have our own simple humanoid robots there. Okay, retail sales people, again, we can have machines to help us. Security guards, I mean, just now we saw that in 2025, even US with the armies, they're going to replace that. So this is aligned with, in line with the soldiers, security guards, soldiers, so more or less, okay? And then we have taxi and bus drivers, because now we already have hybrid autonomous cars, and soon it's going to be fully automated, obviously, and then telemarketers. So when look at this, but we know that machines are coming out. I mean, again, it's to the exponentially increasing. But again, as I mentioned just now, like automated car. So there are issues of security. There are issues of precision. So those are the people that we still need in the area, who has to work about how we can come up with the precision part, okay, the safety issues, okay. So these are non-replaceable jobs, okay. Looks at CEO, clergyman, can be the imam, the priest, okay. Editors, proofreaders can be replaced, but they need to be editors, because they have to be human touch on that. So basically, jobs that will remain for the fourth industrial revolution, whereby we need the human touch, okay. Event planners, it can be automated, but there are some part that again human touch will still be there. Graphic designers, okay. And then we have human resources managers, lawyers, because not all, they are, lawyers, they are also coming out with robots for legal part, but to a certain extent. Okay, marketing managers, project managers, public relation managers, psychiatrists, sales managers, scientists, obviously, because we are the one who's working, scientists and engineers, software developers and writers. So if you are in this on the right hand side, I think you shouldn't be that worried. So, but as I said, the high cognitive skill must be together with us. So, like when I said that transdisciplinary part, okay. But before we go any further, look at this. Okay, even though I was telling you about writers, okay, we still need that. So this is only 25th of October, about 2 days ago, 3 days ago. Okay, so AI sheds light on how the brain processes language. So they keep on coming with the research and to replace whatever that we have currently. So we know that currently we have AI, and it can predict, right? When we are doing our typing, it can predict the next word in a string of text. Okay, but now only recent, in fact, a few days ago, the most recent generation of predictive language models also appears to learn something about the underlying meaning of languages. So, meaning that what's happening is we keep on enhancing our machines, our applications, our software to ease our jobs, to ease our daily jobs. So this is actually helping. But when it's helping, we have lesser jobs in certain areas. So that's about worrying part. But actually, to be honest, nothing much to be worried because there will always be other jobs. It's just that, again, I got to repeat about reskilling and retraining. Okay, let's look about this Sophia. Okay, Sophia, I mentioned earlier. So she has been granted citizenship by the Arab. Okay, she got the Arab citizenship, and now want to have a robot child. Okay, and this is again in October 11th. Okay, so quite recently, she's talking about she's a humanoid robot and a social robot, and they are already going for mass production. But now she's talking about having a child, so meaning that at home later on we can purchase Sophia and we can also purchase the baby. Okay, and then next in line is actually this one is on the 16th of October. First human-like robot nurse to care for elderly, feeling of connection. Because now what happened in robots, they're creating skin as well. Okay, skins like humans, so the materials, not just the machines. So they are putting skins, they are putting like, of course, there will be limitation on the movement at the moment, but we can imagine with the technology enhancements. So soon, the even the movement will be smooth. Okay, and we already have like leaping robot cheetah also been invented recently. So these are something that we should look. Okay, but at the university or in education, what need to be done is we need to explore more into the transdisciplinary so that our young graduates or even that we can give courses to existing people, staffs or workers by certain areas. So this is about artificial engineering. Maybe it's more relevant to the people, our participants here. So now we are talking about AI engineering. Okay, so it's an emergent discipline focused on developing two system processes to enable the application of AI. So you can actually get my slides and you can also look at this one. Okay, so why we need it? Because when we say that our autonomous vehicles function well cruising down an empty racetrack on a sunny day, but then how can it be designed to function just as effectively during hailstorm in New York City? That's what I'm saying. And in Malaysia, if we have quite a heavy rain, okay, we do have a heavy rain season as well. So how that can be functioning? So you can come up with the machine. Engineers come up with the machines. Engineers got embedded things into that. But to a certain extent, we have to customize it. So that's why we talk about artificial intelligence engineering. So meaning that engineers cannot run away from AI anymore. So in our work, in our daily work, okay, just now I said that in our daily life, we are already together with AI. But then looking at our job and our work, we also have to incorporate AI in whatever that we are creating. So no more working in silos, because if you have certain expertise, you have to work together, and the newcomers that they have to blend together with this transdisciplinary. So look at how AI and machine learning use in engineering. Okay, so robots have been used by automobile manufacturers on the production line, and then has gone from completing simple engineering tasks to now handling many precision moves. Okay, so that's why I said that in order to be to get better accuracy and better precision, so obviously we need better algorithms. So machine learnings or AI is actually the way forward for this, and which we are using this already. Okay, so when we talk about our workplace, okay, just now we talked about the job itself. So our workplace, and due to the pandemic, actually is speeding up. Okay, we know that fourth industrial revolution is already there. I mean, coming in 2019, but the pandemic, COVID-19, came in 2020. So that is actually speed up our knowledge. I mean, when I said that reskilling and retraining, so meaning that whether we like it or not, we are all online now. I mean, of course, some of us are used to having online conferences. Obviously, there are sometimes technical issues here and there. But what I'm saying is, with the pandemic, it makes that every each of us, even the students at schools, got to use the software, either Teams or now StreamYard that we're using here, Zoom, okay, Google Meet. So we are exposed to it. We are forced to use it. Otherwise, maybe without the pandemic, we might not be able to move this far. So what we're saying is, again, it increased, rapidly. The AI part is just like without stopping, because due to the pandemic, they are working 24 hours, coming out with better solution for us to help us in work or even in academic area for students. So what we say that now about the workplace. Okay, so workplace now, people are doing hybrid work, or some of us maybe at home, still working from home, but some people are working physically. So look at this. This one here. I hope my mouse is okay. A greater than number of 50% of government and corporate workers want remote working. Okay, a great more than 3 days a week. So they want to at least 3 days at home. And this is actually because we are getting used to the during the pandemic. Okay, but obviously in some sectors we can't. They still have to be physically. But the trend and the workplaces are also changing, because companies also do not need to provide every single space. The way that they design the offices is going to be different as well. So this is actually from McKinsey and Company. They've done a research on about workplaces and works. Okay. So and here 40% say they're still waiting to hear a future workplace vision. As I said, we are already in fourth industrial revolution, but we know that this is going to affect our jobs. But now with the pandemic, we see that the workplaces also changing tremendously. Okay, so next is when hybrid workspace become the next smart normal. So I think now, conferences, we can globally connect it easily. We don't have to fly, we don't have to travel, we save our time. So at times, online conferences are also good, obviously, but we don't have physical connections there. So it can be a hybrid. Hybrid seems to be quite a good way forward. Okay, and then we have ISG. So we look at the number one here. So what people expect here? Okay, we have human, physical, and digital. Okay, so physical is where we are working with whether physically, digitally, and this is about us human. So everyone wants about safe and secure workplace, seamless connection. Okay, physical and digital integration, and then smart facilities, definitely. And we want to have collaboration focus workspace. And then I was learning about my robot recently. So there are plenty of things that are available now. Again, they are using AI as well in whatever softwares that they're developing. And then number 5 is collaboration, communication and collaborations enabled devices. Obviously, we have to talk about having secure cloud, okay, and then automated or proactive technical support is very important. Like just now, so we have a bit of hiccup. Okay. And then we have digital human augmentation and automation. And we have team visualization. Finally, we are going to look at leadership change, contingent workplace, okay, Uberization, and finally is the ability to work from anywhere, anytime. So meaning that if you cannot travel, we can have an online sessions. If we can travel, that will be good. So it's hybrid is actually the way forward. It's no longer physical all the time. So that is about the changes that is going to happen in the workplace. But when I said about jobs, obviously we cannot run away from job losses. There will be, we're going to encounter that. So let's look at about Malaysian environment. So in Malaysia, actually, we already, this has been launched in February, National Fourth Industrial Revolution Policy. So if we look at it, we have present year and beyond 2020. So now we are 2021. So look at this. Presence about artificial intelligence is already present. IoT is already present. Advanced materials, automation, robotics, drones. Okay, we have drones everywhere now. Blockchain. Okay, so of course there are lists of those. So now the future is about 4D or 5D printing, health passports. Okay, and then we talk about meta lenses. Social robots, smart clothing. Okay, so these are something that you can also target it for the younger ones, for our kids or for our future generations, and we have to equip them. So this is actually the Malaysian policy and the Malaysian way forward. So and also we have our science, technology, innovation, okay, and innovation. So my ST here. So we have 10-10. So we have economic drivers, and we also have the technology part. So we look at this. We have socio-economic drivers and also the science and technology drivers. So you look at the top is actually the socio-economic drivers. The science and technology drivers are here. So these are actually the jobs that we are going to focus into, and those that are going to be less and obsolete, something that we have to see on how we can reskill our existing staffs that might not be doing their routine jobs anymore. So basically, those are about that. What actually the impact is going to be with us. That we're going to see that definitely job losses, job obsoletes, okay, and then workplace changes as well. So that's about it. I think it's about we are about time, right? Right. Okay. So that's from me. As I mentioned, that this is just an overall or general view about the impacts that we are going to see with AI coming into the picture. Actually, not coming; it's already with us. It's just that it keep on enhancing. Okay, and the changes is going to be very rapid. The scale of changes and the complexity is going to be with her. So we have to live with it. So with that, thank you. Assalamualaikum warahmatullahi wabarakatuh. I pass it back to our moderator.
All right. Thank you very much, Professor Rosalina, for an interesting presentation on artificial intelligence. It is interesting to see how industrial revolution have significant impacts on jobs and workplaces like in medical, agriculture, military, F&B, and many more fields. I believe the advancements of technology has tremendously geared the changes and revolutions. However, like Professor Rosalina has said before, we cannot deny that humanistic touch is still important in managing these intelligences. All right, thank you very much, Professor Dr. Rosalina, for your time. Unfortunately, we do not have time for the Q&A session as we are running on a tight schedule. All right, moving on. Let's continue with the next presentation, shall we? The second speaker for this session is Mr. Muhammad Shazlan bin Muhammad Anwar. He is the Group Managing Director from Virtual Instrument and System Innovation, VISI. Here are some information about the speaker. Mr. Muhammad Shazlan has a vast experience in aircraft engineering technology and aerospace engineering. In 2011, he established his own engineering firm, And now the company has become the NI Silver Alliance partner and one of the leading NI-based system integrators in Malaysia. Today, Mr. Muhammad Shazlan will talk about industrial IoT applications in the industries. Now, let's welcome Mr. Muhammad Shazlan to deliver his presentation. Mr. Muhammad Shazlan, the floor is yours.
Thank you very much, Pak Moderator. You can hear me well, insyaAllah?
Yes, loud and clear, sir.
Very good. Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon. Thank you for the very nice introduction. Okay. Having a session just before lunch is always quite challenging. I'll try to make it as interesting as possible. So this session is pretty much a sharing session, and my whole objective of doing this sharing is very much to encourage more and more players in the industries to contribute in the development of industrial IoT applications in Malaysia and global nationwide, globally. Okay, so the topic today is, as I mentioned just now, focuses on industrial IoT and specifically in applications in the industries. Okay, why IIoT, industrial IoT is selected is pretty much because if you were to study the market size of industrial IoT, the solutions, all right, you will see that the demand is everly increasing. Okay, and this ranges from, if you go from various market surveyors or consultants, they will show similar results. The numbers may be different, but the trends are the same. It's increasing. Okay, and thanks to the recent pandemic, okay, the numbers here, the trends here are even more increasing than what they predicted before. So the market size, the demand is much bigger and much higher now, right? So this is one example that one quote that was I managed to capture. Right? Okay, global processing industries have reported losing 20 billion each year, okay, due to unscheduled downtime. Okay, and 80% of these losses are preventable. Okay, then by Accenture, 95% of business leaders expect the company to use IIoT within the next 3 years. And 87% believe that it will contribute to long-term job growth. Okay, the presentation before me talked about career improvement, jobs and whatnot, right? So this is one of the areas that while industrial IoT will take away all these manual laborish job, it creates opportunities in the areas of automating systems, programming. Okay, as I showed in my previous slide, the trend is growing. Okay, and in the first quote that people, why the demand is higher and becomes higher and higher, because people have been losing millions of dollars or ringgits every year. So people have been looking for solutions on how to minimize these losses. So with the recent advancement of technologies, so, this will help them to manage the losses. Okay, but before I proceed further, let me just introduce myself a bit more detail on who we are. Okay, my company, we were incorporated back in 2011. So this year we are already 10 years in operation. Okay, our operation is in Kelana Jaya. Okay, you can find us in Facebook, LinkedIn, and if you want to go to YouTube, we have a YouTube channel called VC Academy. Okay, and where we are carrying product branding called VCs. So whenever you see something VCs that's in a way pointed to us, okay, our core competency is in the areas of customized system integration and system development. That means we build systems specific for clients' requirement, based on clients' requirement. Okay. Just now, Puan Moderator mentioned that we are also alliance partner to National Instruments. That means most of our engineering tools, we are using LabVIEW as the programming languages. Okay. So under VC, we have 3 active companies. The first one, Visynergy, is our engineering company. VCTech is our IT company. And VC Academy is our training and talent development company. Okay. And last slide on this is basically, we have been around for 10 years. So these are some of our clients. We have gone to various industries. So not only manufacturing, but we have also gone to aerospace, automotive, R&D, whatnot lah. Okay. So the session today is pretty much, I would like to share the insights that we have gotten by going through all these industries, and how I believe, I'm hoping that it will encourage and all the listeners right now to embark on this. Industrial IoT is a very, I would say it's a very interesting area to go right now, right? Okay, but before proceed again, let me just clarify the differences between IoT and industrial IoT. The term IoT has been used interchangeably, so everybody is using, say, IoT. So what is the difference between IoT and industrial IoT? Okay, this is just to make sure we are speaking on the same language, we are on the same platform lah. Okay. So the first difference is basically the focus objective. Okay, if you are talking about IoT devices, most IoT devices are focusing on to provide user convenience, right? So if you're referring to smart homes, for instance, okay, smart homes is pretty much on to make sure user is comfortable, and user can actually control their aircons and home conditions remotely, okay, and pretty much driven by lifestyles. It's not so much on need to have basis, but it's very much driven based on nice to have basis. Okay. On the other side, industrial IoT, the focus objective is has been around in the areas of safety and improving efficiency. Okay, so manufacturers, when they want to embark on any IoT related projects, most projects will have a tight link with ROI. So when you improve efficiency, you'll see the ROI. When you improve safety, you'll see in the ROI. So that's how the narrative of between IoT and industrial IoT. Then the second point is on the devices. Okay, IoT devices are normally relatively more simple and straightforward, and because the target is more towards the masses, it is price sensitive. On the other hand, IoT, okay, it relates to a more sophisticated subsystems. Okay, sometimes it's not only one devices; it consisted of a few devices working together as one. I'll show more examples on this later on. And these devices must have high reliability, okay, and a long life cycle. And most of these devices is not only to gather data, not only to communicate between what's the device and the cloud. It also has some capability to do edge processing. That means to do some computational work on the edge. Okay. And that being said, the applications for IoT is normally targeting general consumer masses. However, for industrial IoT, the target is pretty much more on specific to industries, which means you normally will not see an application, an industrial IoT application in one industry being used in another industry. Okay, you may see some similarities, but there will be some differences. Okay, because most of industrial IoT solutions are catered specific for the specific industries for each company to obtain the ROI as soon as possible. Okay, when it comes to data, okay, IoT normally provides a lot more data because it targets the masses. Okay, for industrial IoT, the volume of deployment is lower, but sometimes the data being transferred between the devices to cloud is higher. Depending on application. And the last point is on cyber security. IoT devices normally we'll have we utilize shared responsibility method to ensure cybersecurity. Shared responsibility means that it's up to the user or the consumer to protect their own identity and privacy so that nobody breaks in the system. Okay. However, if you go to factories or if you go to the industries, the cybersecurity is a big concern. Okay, so they will normally have their own robust and enterprise level security lah. Okay, so when it comes to industrial IoT, and if you were to refer back to the first point, the focus objective is always either on safety and efficiency, and it must be tied to ROI. Okay, so these are some of the benefits that were collected by Morgan Stanley on IIoT. Why I'm sharing it here is because again, the purpose of this sharing session, this session is pretty much to encourage all of us to go into this field. So whenever you encounter certain issues or opportunities where you think industrial IoT can be able to be used to solve the challenges, these are some of the typical pitching points that you can use. All right. So the most of the time, when people adopt industrial IoT system, it's about improving their operational efficiency and productivity. These two are the most typical ones. All right. Then as you go, as you can see here, moving down, some of them using for business opportunities. Okay. And most of the industries are using it to monitor their performance and assets. So reducing downtime, asset utilizations, okay, asset life cycles, okay. Then one point that shows here is enhancing worker safety. So these are the things that I mentioned earlier. So all these points is something that I believe if you would like to go deeper, it's all available on the web, okay. But do remember, do keep these points in mind when you want to pitch any of your ideas related to industrial IoT to your clients. All right. So you may want to prioritize your pitching points, okay, accordingly based on some of the surveys. Okay. When it comes to architecture, okay, if you can see here, the architecture for industrial IoT is pretty much the same. Okay, we can have outdoor monitoring. Okay, we can have robotic monitoring or even plant control, but that's all everything on the equipment side, plant side. Okay, and from here everything goes to a local server. Typically, industrial IoT will have a local server to process the data and to store the data as buffer. Okay, before the data being sent to cloud. Okay, some organization may have their own onboard cloud, but more and more organizations are relying on the cloud provider, Microsoft, Amazon, whatnot. Okay, because the cost of operating and owning is lower. Okay, and some applications some applications of industrial IoT may require a dashboard, such as dashboard where the operators or managers monitor the data on both sides. Some does not. So this what I'm showing here is basically a generic architecture that can be applied to most of the industrial IoT projects. I'll show a bit more example later on after this. So what I'm showing here is this is basically an example of a typical deployment, of industrial IoT where you may have, consists of cameras, a few sensors here and there, and you have industrial controllers and industrial routers, and this is one site. So you may have multiple sites going on, and then you have a control center that aggregates all the data before being sent to the cloud. So this control center refers back to what I showed here, the application server. Okay. So, well, not all applications will have a multiple parameter type like camera and sensors, but you may have the application may grow to this. Okay. So having said all that, I'll go straight to the applications. Okay, I chose 3 applications that we have done in the past, and I'll share some of the lessons learned, hoping those will assist all of us to go into Indus IoT more effectively. Okay, so the first application that I will talk about is basically on asset and plan management. Okay, this system we deployed it to to the oil and gas industry. Okay, so this particular company, they have a plant, all right? So processing a chemical processing plant. Okay, so this plant will is required for them to do shutdown and turn around every now and then, right? Turnaround means that the whole plant must be shut down and be re-inspected. This is the requirement by DOSH for safety. Okay, so you can imagine during this turnaround, okay, the plant will be shut down for at least 1 to 2 months, and this 1 to 2 months is equivalent to a few millions of loss in opportunity. Okay, that's for turnaround. But every now and then, okay, maybe sometimes every year, certain sections of the plant must be shut down for inspection. Okay, again, this shutdown will impact the production of the chemical plant, and will incur losses as well. Okay, so this is part of the requirement by DOSH, so they can't do much about it. Okay, and secondly, why this requirement comes about is because they have certain equipment that is critical, that is high risk. Okay, when the one of the reason is that this particular equipment, due to the nature of operation, will have cracks to it. So if cracks are not being monitored and controlled, okay, they will end up with a catastrophe. So this is something that we are trying to avoid. Okay, so when the plant is enabled to monitor the crack growth, they will have to oblige to the requirements to shut down their plant every now and then. Okay, and all this contribute to efficiency loss from over planning. Sometimes when they shut down, okay, they have to assume that many things will break down and will be replaced. So they have to over plan their shutdown. Whereas sometimes the replacement is not as severe as they thought. This is akin to if you are familiar with our own car. So let's say our car, every 10,000 kilometers, 10,000 every 10,000 kilometers, we have to send for servicing and maintenance, right? So that is guided by the OEM. So OEM says every that period you have to send for services. But actually, if we can actually monitor how the car is being used, right? So we may need not to send our car for services every 10,000. Maybe we can extend the limit up to 50,000. Okay, or maybe if we use the car very roughly, right? We push the pedal to the floor every opportunity that we have. Okay, maybe instead of 10,000 to maintain the car, we may need to send the car every 8,000 kilometers. Okay, so but without a proper monitoring tool, so we can't tell. So we just have to follow what is recommended by the OEM. All right. So this is something similar, the similar issue with what I'm presenting here. So the deployment that we did at site is basically they have a few called HCFC, okay, hot combined heat exchanger. It's pretty much a heat exchanger, okay, where we put a few sensors around the exchangers, and they have a few of these exchangers, okay, and all these sensors will send data to an edge processor. The edge processor will filter the necessary triggered data, okay, and will send this data back to the local server. And the operators monitoring the control room will monitor from there, okay. So what we are doing, our application is actually monitoring failure crack due to creep and fatigue. Okay, so all this is monitored in real time. Okay, this is pretty much on the on-site on-site deployment. Okay, from the architectural level, okay, we have site A, we have a second site. So this is how things are being deployed. All right, we have the edge processor, then the local server, the control room. All this being sent to they have a central cloud server. They're using Access of Pi. Access of Pi is basically one of the historical database, if you're familiar with it, right? Okay, and from here we have all this data being sent to Azure Cloud for processing. Okay, and then the management and all other people can view the results on the PC and on the dashboard. Okay, besides having data from on-site, okay, on-site is this data, the on-site data relates to the diagnostic capability. Okay, if you're familiar with, if you heard of term, suddenly I forgot the term. Okay, besides diagnostics, they also have this ability to do prognostic analysis. Okay, so prognostic analysis provides data to Pi and to be processed at the cloud server. Okay, so example of the dashboard is something like this. So this is the diagnostic ability. This is an example of their hot combine. Okay, so from this dashboard they can tell, okay, what the current safe limits is not is still within limits. Okay, the probability of failure of the equipment, okay, the remaining life. So this likewise on the prognostic summary, they will have all this something similar in the life of the equipment. So this is the data that they present back to DOSH to as a proof that they have done certain effort to extend the life of their equipment. Okay, as a result, DOSH will grant them DOSH will allow them to operate longer than what they are supposed to. For instance, let's say if every 3 years they have to do turnaround, they have to shut down the plant and re-inspect everything. With all this data, they can actually extend it from 3 years to 3 years and a half. So that's additional 6 months for them turns out to be a saving equals to millions of ringgit. Okay, so this is one example of industrial IoT whereby sensors from site, okay, being processed at the edge and being sent to the cloud for processing. And then on the cloud combined with prognostic data. Prognostic data comes from simulation model that they have developed about on the combine and the whole process. That gives them the life, the probability of failure and equipment life. Okay, this is one application. The second application is on production performance. Okay, this
My name
relates
is
to the
Narshini
manufacturing
Prasada.
side.
I would like to share my research regarding 5G millimeter wave fixed wireless access.
Okay,
I would like to take this opportunity to thank personnel in Embassy of Malaysia in Helsinki. In the photo on the right side is His Excellency John K. Samuel, and on the left side is Mr. Muhammad Arif Muhammad Ali.
Sorry, there was an interruption. Okay, everything's okay back. Okay, so the second application is on production performance. Okay, the application here is for the manufacturing sector. Okay, so in manufacturing, they have this term called hidden factory. Means that normally when a factory is running very busy, okay, they have a high inventory level. So all these inefficiencies are some things that they normally do not see. Okay, inadequate layouts and overprocessing, skills gap, machine breakdowns, all these issues, challenges that they are facing are hidden because the current inventory that they have is able to buffer that. Okay. However, something similar like what they faced last year during COVID, when the inventory goes down, that's when they start seeing, oh, all these issues coming up. Okay. So how industrial IoT can be used to resolve this is pretty much to help them to improve, to provide them real-time data, and to provide them with the ability to make data-driven decision. Okay. So what this means is basically in production. Okay. This is one example. In production, globally, people have categorized the losses into 6 major losses. Losses in production to 6 major losses. Okay, the losses are equipment failure, setup adjustment loss, idling, reduced speed, and defects. Okay, so if you look at here, okay, this is basically the optimum time of the machine. Sorry, this is the loading time. This is the operating time of the machine. Okay, so the machine every now and then will have to stop due to certain downtime. Okay, so you lose certain losses, certain time due to these losses. Okay, then you lose additional time because of the speed is not optimized, or every now and then the machine will have to be minor stoppage, they call it, right? And then this is the net operating Okay, so this concept when combined is called OEE, overall equipment effectiveness. Okay, so it's a concept where it combines data for machine availability, machine and system performance efficiency, and rate of quality products. Okay, so if I were to refer to this slide again, that's how management in all those manufacturing facilities will be able to minimize all these small issues, skills gap due to operators not being trained well, the rejects due to all defected products, machine breakdowns, whatnot. Okay. So the general architecture of the system, okay, on what we provided our client is basically we have our base stations, one station that we put along the production line. Okay, so if the factory have 5 production lines, then we'll have 5 base stations. So all the base stations will collect data, all the OE related data, machine availability, the machine speed or performance, and the defected products, and all this will go into a local server. For us, we call it data aggregator. Okay, and from here, data is being sent directly to cloud for the management to view. Okay, so besides this, we also have options for the clients to have a dashboard to be shown on their production floor. The whole objective is of this dashboard is pretty much to educate the operators of where they are with regards to the production target. Okay. Then on the production floor, so this is an illustration of having 2 production lines where we have 2 base stations on each line. Okay, and we have what we call a counter at each part of the machines to detect the 3 parameters: machine availability, production, machine availability, defected product, and production speed. Okay, from here, this system will help the management to monitor the performance output, the production output in real time. So they will know the current production. So and if there's any errors that leads to machine downtime. So they will have their data in real time and will help them to mitigate any issues in the future. Okay. The last application that we did, that this is something ongoing process, is remote lab access. Okay. The problem statement that we have is pretty much last year. You can imagine students attending all these labs. They do not have access to the labs. Okay, lab assets are I'm referring to equipments in the lab that are being used to teach the students, and you know it's cost hundreds of thousands. Okay, and this, so the first problem refers to what happened last year and part of this year, and the second problem is an ongoing problem whereby normally in most of these labs there's only one equipment, but there are like 20. Okay, high students to equipment ratio. Okay, lastly, the ROI of the equipment. Okay, universities nowadays are being tasked to make additional income, okay, for the university. Okay, so these are three problems that leads us to our system called MyMatMan. Okay, MyMatMan is basically a combination of IT and OT solutions. Okay, where we empower the educators to still provide, to still teach, and for the even though the students are not in the lab. Okay, it's basically we are extending the interfacing the equipment outside the lab. Okay, this solution come about when by us pivoting our solutions that we have deployed in the industry, and we leverage it for the academic users. Okay, the sample labs that can be used can be shown here. So to illustrate what I mentioned just now, you imagine that you have in the lab, you have this robotic arm. So the students are supposed to control and learn about robotic arms. Okay, so this is in the lab, and students are outside the lab. They can be anywhere, either in the home, in in Starbucks or whatever. Okay, and from here, not only one student, we're talking about multiple students having the same access. So lecturers can still conduct their experiments, can still conduct the teaching, and multiple students can view the interface on their own. So almost one-to-one. Okay, the architecture. Okay, this I believe you have seen this throughout this architecture, throughout my presentation a few times already. Okay, it's just that for every application, the architecture is being tweaked a little in order to meet this custom and specific requirement. So this is what I mentioned earlier, whereby as much as for industrial IoT, the applications are similar, okay, and are fundamentally similar, but it's different from industry to industry. Okay, so this architecture is what is how we did for our MyMatMan. Okay, whereby on the right hand side we have the lab, okay, and on the left hand side we have the lecturers and students. Lecturers and students access the lab through an applications on their laptop or PC. Okay, and all the communication from between lecturers and students to the lab are done through cloud, through internet. Okay, so one of the challenges here is basically the infra lah. Okay, so if I were to go on, okay, these are some of the comparison when we did our studies. Okay, I'll skip this, it's already 1 o'clock. So to summarize, what I've been trying to show during this half an hour is pretty much to show that when it comes to industrial IoT, Okay, the approach to provide solutions for our clients are pretty much the same. The architecture is almost similar. You have on the right hand side, you start with all the problems, the devices that you want to install to solve the problems, and then there is data either being processed at the edge on this particular controller or being sent to cloud. Then the users will have access to this data for visualization or even control through cloud. Okay, the differences are on the how and on the what are the problems being solved. Okay, so again, same general architecture and focus on the problems. Okay, the value of each industrial IoT solutions are on the problems that are being solved. Okay, so of course, think big, start small. Right. So what I'm showing here are some of the steps an illustration of the steps to build an industrial IoT solution. It is something again I came across in Google. Okay, and I believe is very relevant to today's environment. Okay, number one, if you, as much as I say the architecture is the same, okay, but sometimes it's very hard for us to have the technical capabilities to deliver the solution end to end. So that's why partnerships comes in. Okay, partnerships comes in on the engineering side to develop the system, and not only that, on the engineering side, you also need a subject matter expert that can advise what are the solutions, what are the best ideal solutions to be deployed. And beside on the engineering, you have on the IT sides to ensure that all this data can be sent to cloud and be accessed by the client. Okay, and on number two, as I mentioned, the focus actually for industrial IoT solution is on the ROI. Okay, it's not on lifestyle. It's not something about being cool, but it's about ROI. How can the company save money or make more money from the system? And of course, start small. Okay. Number four is refers to security. While normally when we start small, we tend to omit security, but in architecting the solution, security is something that you cannot, you can postpone, but you cannot put away for the side. Okay. And last part is architect for analytics. Okay. Sometimes in providing the solutions, you don't need to go into data analytics so much. Okay. However, in order for the solution to be scaled up and in order for the solution to improve with time, analytics and big data comes into the picture. So again, this is something that you may, when we start small, this is some analytics is something that we may put on hold for temporary, but the architecture that we design, okay, must be able to be expanded to cater for this in the future. Okay, with that, I end my presentation. So I hope again the objective of the presentation is to show that to encourage more and more people and to provide innovative solutions for the market through industrial IoT. As I showed during in my first two slides, the market is huge, the demand is high, and it's about time we start building innovative solutions, start solving problems in the industry. Thank you very much. That's pretty much all for me.
All right. Thank you very much, Mr. Muhammad Shazlan, for the informative presentation. From your presentation, we can understand how industrial IoT application serves as the main factor in new job creations, complementing the job losses that are also created by the industrial revolution. However, we must always look for better ways to improve workflow processes and finding opportunities to establish cost-efficient systems. Unfortunately, we don't have the time for a Q&A session as we are running on a tight schedule. Ladies and gentlemen, we have come to the end of this parallel session. We would like to thank all the presenters, Professor Dr. Rosalina and Mr. Muhammad Shazlan, and the participants of this session for your kind participation. As a reminder, please do not forget to scan the QR code for your attendance. We will go for a lunch break now, and we will continue with the next session at 2:15 p.m. Again, thank you very much for your time. Take care and stay safe, everyone. See you again. Bye.
Hi, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to our honorable speakers, respected participants, ladies and gentlemen. Thank you for staying with us in I2ES 2021. I am Mazrul, your moderator for this session. Before we begin, a little bit on the housekeeping notes. First, please don't forget to scan the QR code for your attendance and also the program's ebook. Next, if you have any questions about the topic, please write your questions on the Q&A box. We will address them at the end of the sharing session. So without further ado, let's continue with the program. In this session, we will have three presentations from three different speakers. They are Ms. Nur Shaidah Sabah, a doctorate student from Aalto University, Finland. Next, we have Associate Professor Technologist Dr. Mardani bin Rosli, the Deputy Director of Research Management Center, Multimedia University, Malaysia. And finally, we have Mr. Amiruddin Zahamil, Program Director, Asian Region, Siemens, Malaysia. So stay with us until the end of this session to get the beneficial knowledge from their sharing. Ladies and gentlemen, let's proceed to our first speaker, Ms. Nur Shaidah Sabah. Before the presentation begins, allow me to introduce a little bit about herself. Ms. Nur Shaidah Sabah is a former vocational training officer at MARA Japan Industrial Institute MJII and now as a doctoral candidate at Aalto University, Finland and specialized in communication and networking department. She has worked in the electrical industry for almost 2 years, gaining experience in ST Microelectronic in Muar, Johor as product engineer. And she also involved in industrial attachment for 5 months at Virtual Instrument and System Innovation while working as vocational training officer at MJII. The title of her presentation is 5G millimeter wave fixed wireless access. Again, if you have any question about this topic, don't forget to use the Q&A box. We will address them accordingly at the end of this presentation. Without further ado, I would like to invite the speaker to deliver the presentation. All right, Ms. Nur Shaidah, the floor is yours now.
For giving me this platform to talk for this event, and I believe both of them are joining us today. Little bit about my background. Actually, I'm not the expert. I'm here just to share my research topic, and I really feel honored to get this opportunity to speak in this platform. And also my master thesis advisor is here with us from University of Malaya, Professor Nur Hayati. And currently I'm doing my PhD in Aalto University in Finland. And as you can see, my working experiences is stated here. And I just want to highlight, I was working for MARA Japan Industrial Institute for almost 8 years. And there I gained a lot of experiences and trainings. I still feel like I owe a lot of people there in my development or in my career enhancement. I cannot thank enough like my previous director Haja Zarina, my HOD there, my previous colleagues. I mean, it's like, I don't know, without them I won't be here today. Little bit about Aalto University. It's located in southern Finland, and actually I'm in the Department of Communication and Networking, and actually the lab exists like more than 100 years with original name TKK, and they merged with Aalto University. Previously the lab has a really strong collaboration with Nokia, and as you can see here, I'm stated that in telecommunication engineering for Shanghai ranking, it is number 1 in Finland and number 2 in Nordic countries and number 5 in the whole Europe and 34 in world. If anyone interested, you can look at this link for the virtual tour. It is really well equipped for telecommunication engineering, I can say. The demand of high data rate is increasing due to more devices need to be connected to the internet. And also the usage of data is increasing due to the live streaming video, and even for the recent pandemic, COVID-19 make us work from home, need to learn or teach from home or online learning or teaching, even do the online grocery shopping. I can say that internet access is a necessity, not a luxury anymore. And it is even become a basic right. And UNICEF and ITU report mentioned that 2/3 of world's school-age children, or equivalent to 1.3 billion children, don't have connection or internet connection at their homes. And this means that they might lose learning due to the school closure, due to the unprecedented pandemic. So we can say that how this internet connectivity or infrastructure is become important and crucial. If I can share, in Finland, there is only 5.5 million people throughout the country, and the population density is 18 persons per kilometer squared, much lower than Malaysia, even lower than Sarawak. But I can say that the internet connection is quite good, and even it is in the affordable price, I can say. And maybe we can look at how this effect, maybe one of the factor, and as we know that Finland is a best education in the world. In order to support the higher data usage, we can put more antenna, and can be used to support like beamforming in millimeter wave usage. And also it will also can contribute to the higher gain, because more antenna can be fit in the same size as the larger frequency. And I mean, here it also showing that terahertz, this might be like next 6G frequency. And also in the visible light communication, also quite a hot topic. In this figure, I just want to show that, I mean, yeah, it's from Qualcomm, actually one of the big chipset manufacturer for 5G. And in the US, there is already a phone that support millimeter wave for 5G, not just for sub 6G. But if I get it correctly, like in Malaysia allocates frequency for 5G, which is 700 megahertz, and as well 3.5 gigahertz, which is under FR1, and for FR2, Malaysia allocates 28 gigahertz. I was explaining the benefit of using millimeter wave frequency before, but actually there's a challenges of using this frequency due to the smaller size or balloon, there is a benefit by using fixed wireless access, because if we take this satellite or geo satellite, which is will be always on top of the same place, or on top of the Earth position, so it will the link need to travel, or the data need to travel like more than 35,000 kilometers, and this will cause a delay. But if you use the fixed wireless access like on the top of the tall mast or tower, or we call it base station here, it will be fixed line, and it will be can be less than 20 kilometers. And if you use the millimeter wave connection, 5G millimeter wave connection, it even can support like higher data rates. And because there might be a place that not economical to put fiber optic to that user, maybe it is in like rural or in the mountain area and so on. So there is the fixed wireless access wind in this sense, or benefit. And I mean, the user can be like in this rural school area, which is there's no fiber optic connection, or there's no wired connection, or there's no possibility to put any wired connection direct to that place, like maybe in the community center in the rural areas, in the maybe in the little bit forested area and so on. And then from the fixed wireless access can be connected to the internet via fiber optic. But there is a point that satellite communication might be useful, in my opinion. Let's say you need a connection from the sea, or the vessel that travel. Yeah, so basically you don't have a position, fixed position in that sense, then satellite communication might be useful in that sense. So as I mentioned before, for fixed wireless access might be that a good solution for the place that cannot get a wired connection directly, or optical fiber optic connection directly to the user. And it can be like fiber optic than fixed wireless access. It's like a hybrid solution for a last mile connection from the central unit. And then this is like to show that now, because of the more antenna is capable for millimeter wave, so this base station can do the beamforming to the specific user. This is to show that this is non-beamforming. That means from the base station, it radiates, in the large area, or maybe sometime using omnidirectional antenna, and a lot of energy also being wasted or in the large area. But if we use fixed wireless access, we want a specific user to get the signal or the beam, so we will target a specific user only using the beam. So this is also will give the benefit of the lower frequency, because it will have higher propagation loss, but because we use beamforming, we can focus all the energy to the one user or to the specific user using the beamforming method. Okay, so this is the one of the in the news actually released by Nokia, Qualcomm, and US Cellular, which is it says that the success to do like 5G millimeter wave fixed wireless access in like a really huge range, which is more or less 10 kilometer with average downlink speeds of roughly 1 gigabit per second, and the uplink speeds reaching approximately 57 Mbps. And they even also can go like more than 11 kilometer with the 750 Mbps downlink speeds. Okay, for this research, why we did it at first place? Actually, because last year, July 2020, 26 gigahertz band became commercially available in Finland, and one mobile network operator in Finland, which is one of the biggest one, Elisa, want to understand what is the channel propagation in Finland, especially in Finnish rural area. Even for fixed wireless access, line of sight is needed between base station and the user, but we also want to understand what is the effect if there's a blockage in between, there's a building in between, there's a forest in between, because actually in Finland more than 75% of the land is covered by forest, so it's really a high forested country, yet the internet coverage is quite good, I can say. But operator in Finland, which is one of the biggest one, Elisa, want to understand what is the channel propagation in Finland, especially in Finnish rural area. Even for fixed wireless access, line of sight is needed between the station and the user, but we also want to understand what is the effect if there's a blockage in between, there's a building in between, there's a forest in between, because actually in Finland more than in this actually done with is lack of information in channel measurements, and we also did in a few
All right, ladies and gentlemen, sorry for our technical issue. Now back to Miss Nur Shahida.
Yes.
Hear me, Miss Nur Shahida?
You can hear me, is it?
Yeah, I can hear you clearly.
Yeah.
Okay,
Yeah, all right.
I pass back the floor to you. Thank you.
Yeah, all right. I will start from where did the problem begin.
Yeah, sure.
All right. So I will share my screen. Let me know if you can see my screen now. Can you guys see my screen?
Not yet.
Not yet. Okay.
Yeah, me.
All right. So
All right, so we can see
yeah,
your screen now.
it's good. I mean, it is interesting because even it is a technical issue, but what we can see here is like how important the bandwidth is, because we're streaming the voice and the video at the same time. So there is the millimeter wave win in this sense,
Yeah.
So I will continue here. So why I did this measurement, because in Finland we have the 26 gigahertz commercial available. So so we want to understand, because in Finland, mostly forested country. So yeah, okay. So I will proceed. This is the measurement that I did. So we did a measurement campaign in 5 locations during the summer, because we want to see the effect of the foliage, how the tree effect. And this is the actually the southern area of Finland. So this is the 5 area that we did, and it's really interesting because we try to mix up a different area, urbans, rural, and suburban.
Sorry, Miss Nur Shahida, for interrupt.
Yes.
Can you share your full screen?
Oh, okay. I will try, but I will delete this first. Yeah. I'm afraid it was speaking.
Share the slideshow at the
Yep.
the bottom parts.
Yes.
All right. Thank you, Miss Nur Shahida.
All right.
So please
Okay.
continue. Thank you.
Okay. I will try to make this thing not talking. All right. Okay, so this is the one of the place actually on the roof. We did one measurement. So as you can see, this is the equipment, the antenna, and so on. And then we also did on the tower, one of the mobile network operator. So we put the receiver on top of the tower, and then the transmitter on top of the tower and the receiver. Okay. Okay, so this one, yeah, I need to delete my voice, everything. If not, it will speak. Sorry for that moment, because I prepared this before, and then, yeah, I know it is a bit clumsy. And then this is the hardware that we are using. So this is antenna. We use a Keysight generator, amplifier, and also the receiver. Okay, so this is the result that we get. So for the different antenna heights, it's more line of sight condition, and every 20 meter increase of the transmission antenna height or base station, the path loss mean improves 4 to 6 dB, and the measurement suggests tall masts can be reused for fixed wireless access at millimeter wave frequency, and increasing antenna height will improve the cellular coverage, and the path loss estimation we use also to evaluate the using the map of the channel model. Okay, okay, so okay, so this is the result. Also, one of the result that we use a laser scanning map. So to understand what is the blockage between the transmitter and the receiver. As you can see, so we calculate that in between there is a tree. We can calculate what is the distance, and we can map that using the channel model. And then we also find out that even is a really large blockage in between, but the vegetation attenuation below 40 dB. So basically millimeter wave still can use, even, I mean, might can be used. So, and then the last slide, it will be, okay, so as the conclusion that it's really important to understand the radio channel before we design the networks, because you need to understand that, okay, what it okay, it is, yeah, it has something. So basically, as Malaysia already have allocates a few frequency for 5G, 700 megahertz, 3.5 gigahertz, and 28 gigahertz. Basically, a thorough research needed because we want to understand how many base station we need to put. Maybe it's not the same, the forest in Malaysia and other country, because most of the research of millimeter wave, I can say, been done by in Japan or in the US. Like one of the famous Professor Rappaport, is doing thorough research also in millimeter wave. So in context in Malaysia, we should have also to understand this before we design our 5G networks, I can say. So the information regarding the blockage also essential for fixed wireless access, because we want to understand what is in between. Is it the building? Is it the tree? So in this sense, our country also need to be prepared, like to have the laser scanner map or maybe LiDAR map, so we know like a 3D condition or geospatial data. And a lot of significant number of research topic, like unlicensed spectrum, like maybe 6 gigahertz, or non-terrestrial communication system like drone, or drone, balloon, and this is also to support IoT, it been said so. And also now is also famous about ORAN, Open Radio Access Network. Yeah, so far that's all my presentation. Thank you, and sorry for whatever technical issues. Yeah.
All right, thank you, Ms. Shaida, for the informative and interesting presentation. All right, ladies and gentlemen, now we come to the question and answer session. But before that, if you haven't scanned the QR code, please do so. All right, Ms. Shaida, it looks like we have a question from the audience. Okay, the
Yes.
first question is from Mr. Felix. And the question is, based on your research, what challenge that you face in order to use millimeter wave?
Okay, interesting question. So basically, the hardware or the equipment, because we need to make sure all the antenna, all the cables able to use in this frequency. Yeah. So, and the position as well.
All right. Okay, thank you, Ms. Shaida, for your answer. Okay, they have another one question. Is from Ms. Melissa. And the question is, how about the accuracy and latency information transferred through millimeter wave?
Okay, so basically, a lot of things involved about the latency in millimeter waves, like the TTI or the length of the packet. But for my research, actually, I just use the sine wave, so we don't measure, we don't see in that sense. Yeah.
All right, thank you, Ms. Nur Shaida, for your answer. We have another question actually, but unfortunately, we don't have so much time for the Q&A session as we're running on a tight schedule. All right, again, thank you, Ms. Nur Shahida.
All right, thank you
ladies
for
and
having me.
gentlemen, finally we come to the end part of this presentation. We would like to say thanks again to presenter for the information and interesting presentation. All right, before we proceed with the second presentation, I have just a little bit of a reminder for the audience. For those who have not scanned the QR code, you can do so now to record your attendance. Now, before we proceed to the second presentation, let's have a commercial break first. Thank you.
UniKL, kita datang. UniKL, jadi cemerlang. Universiti Kuala Lumpur mercu tanda pendidikan MARA. Sertai kami bagi pengambilan.
Welcome back, everyone. All right, we are now moving on to the next presentation. I am pleased to introduce our next distinguished speaker, Associate Professor Technologist Dr. Mardini bin Rosli, the Deputy Director of Research Management Center, Multimedia University, Malaysia. He served as Deputy Director of Research Management Center, Multimedia University, President of MMU Mesra, and Chairman of Center of Wireless Technology, Multimedia University. At international and local level, he is an advisor or immediate past chair and was chairman of IEEE Malaysia in Communication Society or VTS for 2019 until 2020 and currently serves as vice chair of Malaysian Radar Navigation's interest group MyRAN IG, Malaysian Society for Engineering and Technology, MySET. He is also the founder of Armada SmartTech MR Sdn Bhd spin-off company and registered chartered engineer with Engineering Council United Kingdom and member with the Institution of Engineering and Technology IET UK. His current research interests are 5G or 6G telecommunication, D2D satellite, Internet of Things, and radar communication. He has published 140 papers for index journals, conference proceedings, professional magazine, and book chapters at national and international level. He has been involved in industry consultation and collaboration with some companies, private and government sectors. Besides, he has been invited by IEEE International Conference as keynote speaker, invited speaker, and plenary chair for over than 10 countries for 2009 until now. The contributions to academic and the engineering professional over the years have earned his recognitions nationally and internationally, awarded 45 international and local awards. Without further ado, I would like to invite the speaker to deliver the presentation. Doctor, the floor is yours now.
Assalamualaikum and very good afternoon, everyone. Can you hear me, right? Can you hear me?
Yeah, we can hear you, Doctor.
Or sometimes can hear. So,
yeah.
Okay. Thank you, Mr. Chairman, for the very kind introductions. Okay, I'm Mardini from MMU, Cyberjaya Selangor, and I'm from Research Management Center. And inshallah for today, I'd like to the duration given to me is around half an hour, 30 minutes. Inshallah, we'll try to share a few things regarding one of the topics that's we are working today. The title here is on the 5G and IR 4.0, which is considered as a future demands. Before I start, I think I would like to congratulate and also thank you very much to the organizer, our Malaysia-Japan National Institutes, and also the other agencies that successfully collaborates with MJII. Okay, and thank you very much again, sir, for inviting me and also other speakers. It was very, it's very good session, sir, especially for today, since the beginnings of the slots. Okay. First of all, on behalf of AMU, I'd like to thank you very much to all the participants, to the audience today, joining this collaborations event organized by MJII. I am from MMU Cyberjaya, and we are now under Center for Wireless Technology, which is one of the research center under Faculty of Engineering, Multimedia University Cyberjaya. Okay, and also on behalf of IEEE, Institute of Electrical Electronic Engineering Malaysia in ComSoc and VTS joint chapter, we would like to thank you very much as invited our chapter to be the co-organizer for these events. Okay, so for IEEE ComSoc, we have a few members come from around 7 to 8 varsities in Malaysia, mostly from IPTA, and Today we have around around 250 members around Malaysia, and we are the among the active chapters in Malaysia. So if you have any further questions, feel free to join our chapter as a member. Okay, you're welcome to join. Okay, so in our faculty, I mean our university, MMU, we have 10 faculties. Okay, and from FOE, Faculty of Engineering, and we have also other faculties. We are working together in collaborating with the agency, collaborating with the universities internationally and also nationally in cross disciplines. So it means some of our staff, they are very active, collaborate. For example, from engineering, they collaborate with management, they collaborate with the IT. So we are now working in the cross disciplines. Okay, so this is our faculties and also our universities. And as I mentioned just now, I'm from Center for Wireless Technologies. This is one of the research center part under Faculty of Engineering, FOE. In our research center, we have a few interests like the 5G, 6G, mobile technology, IoT, AI, radar, antenna, microwave, propagations, energy, and so on. Okay, and mainly we are working on these 4 fields on the 5G, 6G, mobility, communications, microwave, antenna. If you have any further questions, basically looking forward for collaborations, feel free to email me or maybe you can drop your text in my phone number here, 019267997. Okay, so I can representing our research center, okay, for any future collaborations. Okay, inshallah. Okay, few running projects under research centers, mainly working on the, we have 5G testbed, we have NHS chambers, we have drones, and few more IoT products and also prototypes from our research centers. In our research centers, we have around 13 members, 13 members working together in more to the wireless communications field. It's not limited to wireless communication. We're also running on some mathematical or IT domains, especially on the AI, on the VR, virtual reality, and so on. So, but our main domain here is more to the wireless communication. That's why our research center here is the Center for Wireless Technologies. So we are located under the Faculty of Engineering, MMU Cyberjaya Selangor. Okay, so these are the 13 staff, okay, under our research center. Our research center also quite active, aggressive in collaborates with some agencies like TMs. Also, we have collaborated with ZTE, MCMC, MIMOS, and a few more. Okay, mainly focusing on the wireless communication as well as other domains related with wireless communications. Okay, so these are some of the industry and government agencies that we have engaged before, and also we have running some projects, joint project together with these industry companies. Okay, and okay, inshallah for today, that's a very introduction for my background. I mean, on the research centers, my university, and also my associations, ITPE, Communication Society and Vehicular Technology Society. Okay, inshallah for today, I would like to share one of the topics, okay, which part on the wireless communications. Okay, maybe some of the audience come from different backgrounds. Okay, I'll try to shorten my presentation and try to make my presentations more simpler in making everyone's can understand what I'm trying to share. And these are the 2 topics that I'm going to discuss today. And inshallah, the first one is on the what, why, and how the future trend of telecommunication technologies. As we know, telecommunication technology is demanded today. As we feel, especially this is quite important, especially during this MCO. I mean, during this COVID-19 pandemics and also future endemics and so on. So this telecommunication technology is really play a very big role in giving benefits for all the users, regardless you're working in the industry, you're working in the university or any sectors. So what I'm trying to share here is about the IR 4.0, Industry Revolution 4.0. Of course, we have a few generations before, especially on the IR 1.0, 2, 3, and also 4. Okay, part of that, when we're talking about this IR 4.0, they have a few domains, and what I'm trying to share here is about the 5G. 5G is one of the topic demanded those days, and under this 5G, I'm trying to share about D2D, device-to-device communication. This is one of the areas under 5G networks. Okay, so these are the two things that I would like to share within this 20 minutes times. Okay. At first, it's about the IR industry regulations. The question here is, what is an industry regulation, IR? Okay, this is actually something that can change our life, can change how we live, can change how we work, and can change how we communicate with the pupils, with other, with other countries, in different areas, different countries, in different platforms, different devices, and so on. So, in other words, this industry regulation is very important. This is for our future, and so it's already proof in the previous IR is actually solved so many problems in our life. Okay, so if people want to know more about this IR, the answer is here is something can change how we live, how we work, and how we communicate. So of course, these three components becomes our important keywords nowadays. When talking about this IR is actually is, in other words, is actually the transitions from hand productions method to machines. That means from humans, we convert everything, we transit everything to machines. So I mean, it's more robotic and more safely, and also this is applicable for today, especially during this COVID-19. Everything is we require this technologies. Okay. When talking about this IR, some of the technology that's we have is a self-driving. Example is driving. So it's very important, especially for the old driver, even for the young driver. We trying to minimize our energy. So we need this kind of technology, self-driving, to help us to go for the destination safely and perfectly. Okay, so this is one of the technologies, and also they have a flying car. As we know, everywhere, like in Malaysia, everywhere is heavy traffic jams. So that's why they have a lot of projects working on the flying car in order to reduce this burden to the people in Malaysia and also other countries, and that's having a very high traffics everywhere on the road. And also, it's very proof today. We have, especially during the MCO since last year, online shopping is quite famous. And what we have today, we have a Grabs. Help us to deliver the goods that you bought to your order reach at your house. So for this technology is we're expecting we can use the drone instead of the Grab. I mean, instead of the human. So we can use the drones to deliver your goods or your order reach at your house perfectly. So this is kind of the technology that's demanded. And maybe you have a question why we need this IR 4.0 is because of this 4 reasons, in terms of the cost, in terms of the customer, in terms of the complexity, and the fourth one is in terms of the competitions. So it's quite, we look at this here, the first one is in terms of the cost, of course, we trying to eliminate the waste and also the losses. That's why we need this technology. We need these evaluations for everyone. Customer, we expect what? It's a fast, cheap, and high quality products. So that's why this is what we want. And also in terms of complexity and also the competition also is quite demanded. Competition. Everywhere they compete each other to come up with the better products. Okay, let me quickly share about this IR 1.0. We have steam power before. We have steam power before, and 2.0 we have last time's electricity. And the third one, IR 3.0 is the famous one is the 3D printings. And this 3D printing is quite famous until today also. Is especially in the university. They are most of the students, most of the researchers, they are printing 3D in their products. It's easy for the lecturers to explain to the students. Okay, and how about this IR 4.0? They have a lot, especially what we can see. We have AI, artificial intelligence. We have VR, virtual reality. And here, what you can see here is instead of human, instead of medical doctor treats the patient. So we are using these technologies. I mean, this IR 4.0. We translate from humans, from human to robots. So I mean to the machines. So I mean it's you can be monitored remotely. So I mean it is safe technology. Okay, for all the patients, for the patient, and also it's good for the medical doctor. To reduce the risks. For example, this COVID-19 is easy to be spread out. That's why we should have a better technology, especially on remote monitoring the patients and so on. So I'm not going to touch more on this IR 4.0. What I'm talking here is we have 5G. We have 5G. So when we're talking about this IR 4.0, there are a lot of components that we may consider. Especially in our teams. We have IoT, as we have so many good presentations today. And also we have so many good presentations from our previous presenter on the wireless, mobile technology, and so on. So my focus today is only on the mobile technology. Mobile technology means that mobile technology is one of the subdomains under the Industrial Revolutions 4.0. Okay, actually they have lots. And all are important for everyone's. I cannot say mobile technology is the most important. Actually, all are important for everyone's. Okay, when we're talking about this mobile technology part under this IR 4.0, we may have questions, especially on the 5G. What will be done by the 5G and how, and also probably requirement technology applications. And also when we talking about this 5G, I can try to go more deeper on the 5G technology, which is the D2D, which is stand for device-to-device communications. Okay. When we have this question, these screens, what is this? I think this is very common for everyone, regardless your age, regardless your countries, regardless your universities, institute, or whatever. Everyone can guess what is this. So this actually is our life. When we wake up in the morning, means after subuh prayer. So this is the first thing that we will do every day, opening the handphone and so on. And also when you go before you sleep, also you are working on this. You're opening, maybe it's become the last message for you on the day, and then you sleep and so on. So it means that this is our life. And also you can see here, this is important for everyone, everywhere, anytime. You can see here is used for mobility, used for Means, for example, the searching the places, and also use for especially in some countries like Japan, China, Korea, they are widely used in the speed train, underground trains at their countries. Okay, so in Malaysia also we have this kind of demanded technologies. Okay, we're talking about this 5G. Same with the IR 4.0, we have IR 1.0, 2, 3 until 4, and so on. In 5G also we have a few generation before, as known before. We started with 1G, 2G, 3G, 4G, and here is approximately the generation is changed every 10 years. Okay, and we have once the new generation it come together with the new applications, new technologies. For example, we started in the 1G on the analog, digital voice on the 2G, mobile bands. On your phone, you can start. The user can start to browse the Gmail in the mobile phone. Also, we have using a smartphone in the 4G in year 2010s. So it was 11 years ago. We use for mobile internet, which is more faster and more better technologies for everyone. Okay, so and 5G 2020 expected last year. And also in Malaysia, we are very soon. In release this technology. Okay. 320. Okay. This is how the mobile phone system works. How it works. Actually, you start from the mobile phone, and then it sends to the BSS, base station subsystem. And they have sent to the MNO, mobile network operator, like we have today. We have Celcom, Maxis, DG, and so on. Okay, and it's up to the users or the subscriber. If you want to make a call, you will send direct to PSTN, Public Station Telephone Network. And also, if you want to browse internet, or maybe you want to WhatsApp someone, and so on, so you will go direct to the public internets. So it means they have two option after you reach the operator. So you can go either PSTN or public internets. Okay, and what we have today is, in year 2021, it's proof since 5 years, since 10 years ago, the number of mobile phone is increased. It was increased since many years, and then it come together with the increasing of the traffics. Increasing with the traffic. You can see here. This is the statistics. In 2016, it just 5 years ago, is around 7.2 exabytes, and also in year 2021, they have around 7.4 growth. It's around 49 exabytes per month. So it's a quite aggressive. You can say here is the exabyte per month is increased drastically. It's very fast. And also, we look at this traffic. Started from year 2010 on the 4G, where the traffic was 1.5%, where it was only 0.2% connections. On the 5G is reached 75% traffic. That means it's quite high improvements. It means it jumps so fast. Where it come together with the 53% connections. Okay, and in year 2021, today they have expected is around, they have 98% traffic using the smart device. So there was, for example, today we have around 75% connections. So this is the statistics, and also from what you can see from this diagram, you can do a forecasting for 10 years, for 20 years from now. So the graph will be increased drastically. So this is the reason why we need our industrial revolution, as well as these mobile phone generations. So look at it here. This is I can say this roadmap for 5G, 6G networks. So they have a D2D on this under this 5G or even the 6G, and this 5G is quite common for everyone, but not many people, maybe they're not really aware, or maybe some very champion on the 5G. So we may have a question what 5G is. Actually, it's for everything. It's actually for our life, and actually this is for future demands. So you can look at here is for smart. Everything is smart. Smart wearable, smart mobility, smart parking. And also what we have today is smart phone. This is the first thing that we have to develop. It was developed since our 4G, and of course, for example, in university, we try to transform into the smart campus, or maybe in the most of the government agency, they become the smart office and so on. Okay, 5G is quite important, as we know this one is a technology that connecting the community. In other words, it's helped us to connect to everyone's, connect the community, regardless your places, regardless your areas, and also regardless your devices. And it's already proved during this MCO is quite important, this technology for us. And of course, we don't know when this this endemic will over. There is no question, there is no answer until today. So the answer that we have today is this technology is demanded because of this pandemics. So I mean, this pandemic actually is not giving a full drawbacks. Actually is open up for all the researchers to come up with a better technology, especially on the 5G in solving this problem. Okay, especially on the medical, especially on the engineering, IT, and so on. Okay, we may have a questions why we have to stop 4G, or in other words, why we need why 4G is not enough. So there are three reasons. At first is this is the most common one. It's not good or not suitable for the bursty data traffic, and suitable for business traffics. So as we aware, the number of devices increased, so the data traffic is definitely increased. So this 4G is not able to cope this problem, and also inefficiency at the base stations. I mean, at the base station, it's like the parents are not able to take care all the children and so on. And also another problems that 4G may not able to solve here is on the interference. Interference is everywhere, and also not able to support for the heterogeneous network. So this heterogeneous network is actually this is demanded, and previously we have a homogeneous networks. This one 4G it may not able to support. Only a few projects that able to support these heterogeneous networks. Okay, and also for the indoor and outdoor, we know the users, they're coming from two type of users, indoor and outdoor. For 4G, there are no separations. So for this 5G, it may have no limits, and it's good. Okay, they have challenges. We have challenges in the 5G, especially on the data rates. Should be high speed as possible, and also in terms of the scalability, flexibility. This is what we want. And just now in the slide, 4G not able to cope to the interference. So in the 5G, we know even the traffic is increased because of the increasing of these mobile devices. So this 5G, it may able to minimize. It's not zero-rise. It's able to minimize the interference. Okay, and also there are the few reasons in terms of the latency, optimizations, economic impacts, and also high mobility and hover, especially when the users are moving from one cell to another cell, or maybe from one region to another regions, and the signal may drops, or maybe the signal quality is not good enough as compared when you are not moving. So this is something that 5G may able to solve. And also in terms of security, we know 5G is quite intelligent, but is considered more secure than 4G. Okay, few challenges that we may face here, especially on the coverage, especially in the rural areas, like in Malaysia, there are a lot of places in rural area in Malaysia, we have to solve on the coverage. And also the other thing is in terms of the speed, in terms of the speed as well. And actually they have lots, but we may focus only very few in our interests. So for example, in our research center, we are focusing on the very few, especially on the coverage, on the density, capacity, data rates, improving the speed, improving the security, and so on. And even some of our staff, they're working on the spectrum mobility in to take this challenge of this 5G. And 5G is quite good, quite important for us because it's able to solve our problem today, especially on the mobility reason. And also, for example, everything we do today is manual, and then when we go for this, when we reach the 5G, everything is become automated system. Okay, and for example, you go to the shopping complex, you can use these technologies to find the shop directly instead of asking the people or humans involvement and so on. So let me quickly go to this D2D. Device-to-device communication is D2D stands for device-to-device communications. So it is defined as direct communications between two mobile users without traversing the base stations or the core networks. So it becomes the technology that able to solve two things. One is the coverage. Second one is the speed. So it's because when we're talking about the speed, it's because what we have today, everything's the mobile phone will go through the nearest base station to do everything or any tasks. For example, you want to send the message, you want to send the video, and so on. So the information will reach at the base stations. So instead of communicate directly with the base station, so you can skip that part. So I mean, you can increase the speed. The processing speed. And then the other thing is this technology also able to increase the coverage. Because we understand nowadays everything is online. Everything is robotic. So that's why we require this technology for our life. That means better speed and also higher coverage. For example, here, mainly use for B2B. Many of us, we aware on this technology, vehicle to vehicles communications, and also content distributions, local advertisement, doing business online and everything. And also it's not only for money purposes and also for safety purposes also, mainly used for public safety. So this is a kind of improving the previous 4G technologies, and that's having a higher delay and also low coverage. Okay. The advantage, we have the reason why we need this technology, especially on the growing demand in local wireless services. And then, as I mentioned just now, everything must go through the base stations. So what we have today is actually increase the burden at the base stations. And when the base station, they are headache, they are so stressed. So that's why it can cause, it can have a side effect. It's like the human, when you have so many work, you're so stressed, then sometimes you can't, not able to control your emotional and so on. So that's why it can giving a side effect. So the similar with this concept, the base station is like the human. So we should make the base station happy. So it means like the human, we should make everyone happy. Okay, and then the other thing is bandwidth. Bandwidth is very limited. Okay, the reason why we have this D2D is because of decreasing the delay, because it's not go through the base stations, and also it can decrease the loads at the base stations. And the important here is it's able to increase the throughputs. When talking about this throughput, of course, they have a few factors that affect the throughput. Example, relate with this throughput, like the coverage and also the speeds. So this is what we demanded for today. Okay, I don't think I have sufficient times to run some video or some animations, simulations. Okay, I think I only able to explain on what I have in the slide. Okay, we're talking about this D2D. They have interference. They have interference that can cause, in other words, it can affect the performance of our system. So when we look at here, it's very common when we introduce a new technologies. It's come together with the new interference. So what we can look at here, they have a lot of interference created due to this new system. For example, between mobile phone and other phone, between mobile phones with this D2D with the other mobile phone without the D2D, and also between the mobile phone also the base stations. So it can create a lot of interference. Either it's uplink or downlink. Okay, so this is kind of the interference that we have, and some of the project that we have in our research center, we have a prototype, we have a test beds on the D2D. Okay, we are using this device in measuring our signal since 4G, LTE, LTAA, and also 5G. And we have a few projects running using this device. And some of our researchers, they're working on the developing the algorithms. Some they're working on the developing the prototypes. And some of the related publications under these projects. We have a Velocity Away and Hover. We have a project on the RF energy harvesting. We have a project on the TDMA beamformings. We have a project on the quad bands, stack hybrids, RF solar harvester, and also they have a project especially on designing the algorithms for self-automations and used for LTA, long-term evaluation advanced, and also 5G headnets. Okay, these are some of the related publication. And if you have looking for the collaborators, feel free to contact us, especially at my research center. If you think they have a potential to collaborate, you're welcome to collaborate. Okay, some of the D2D projects. This is the fifth papers. That's the fifth project that we have here is set up this D2D. We have this setting these parameters on the carrier frequency, outband, also the inbands, and we have also setting the interference users, and also the D2D links. And in one cell radius, in one cell we have set around 500 meters, and we have a noise power density we set around -74 dBms per hertz, and so on. And so we have a transmitter power for D2D and also for NT, so interfering users. Okay, so this is our setup. So I mean, in one environment, in one locations. So this is the setups. We are setting base stations in the middle, and then they have a few interfering users, and also they have a few D2D which transmitting. So we are designing the setups, and we're designing the algorithms. We are designing the algorithms at first initializing the network parameters, calculating the distance between the D2D devices. And then we may have a questions probably how long this D2D can go. So in these projects, some of the project here, we set 15 meter is our maximum distance. So we tested for below 15 meter and also more than 15 meter. Okay, and here we tested for two different methods on the spectrum. At first is dynamic, second one is a statistic system. So we're designing the dynamics algorithms, dynamic purpose algorithms, by applying this method on the left hand side here. Okay, so from this setting, we come up with this results graph. So what you can look here is in terms of the signal interference noise ratio, which is one of the parameters in measuring the performance. It show the proposed dynamic systems showing much better results compared with the static. Of course, dynamic is much better than the static. And then we are comparing also between out and also in-band spectrums, where out-band is in-band is much better than this out-band. Okay, and then we tested for throughputs for the distance between the two devices of D2D. We started with 0, 10, 20, and furthermore, is showing the throughput is decreased when the distance between the two devices on the cell radius just now is increased. And then we compare against between this dynamic and also this in-band also out-band spectrums. Okay, and also we tested on this number of interfering devices. Okay, where it clearly show the higher number of interfering devices, which is 20, showing or giving a low throughputs because of it creating a lot of interference. You can imagine in one particular area, instead of 5, they have 20 devices interrupting your mobile phone. So this is showing cause reduction of the throughputs. And also on the distance between D2D, it also is getting dropped, the throughputs. Okay, so that's the D2D 5G projects that's means in the previous discussions. And you may have a questions why we need this is because to produce it means to achieve our final goal, which is smart city developments. So for example, here we are supporting on the mobile technologies. Our D2D, our 5G is a very small, very small components in contributing towards the development of the smart city. Actually, we need a lot. For example, here they have some project working on the, of course, very famous IoT. There's some project working on the smart parking. Okay, so our team, we are focusing only on the this IoT, mobile technology, smart parking, the traffic management, smart energy, and also smart home. This is our focus in our research center. Okay, and some use case that we find out here is on the smart city, smart home, wearable devices, fitness. Everyone is very important, especially this COVID-19. Fitness is very important. Remote sensors and also object trackings. Let's say the car is stolen, so it's a good technology for us to track to get back your car. This example of the use cases. Okay, any other project that's running, and then we're looking for the collaboration here, especially on the interference, resource allocations, power amplifier, beamformings, development of the algorithm scheme for the interference management, and some working on the connective radio in the 4G long-term evaluation advance. And then we have we are funded, our projects are funded by some of the agency like MOHI, MOSTI, TM, CRES, PPRN, and FIMOS. Okay, so these are some of the running project and some of the completed projects. And of course, what we do today, we have reasons, and of course, is to support the governments and to support the worldwide demanded why we need 5G is to produce the better employment opportunities. For example, in 2035, which is around 14 years from now, the expected is around, I can produce the gross output around 3.5 trillion. This is the approximated value. Employment is around 22 million. You can see this number is quite high, and it's not the dream. Actually, it's something that we're going to achieve in 2035 because of what we have today. So again, on behalf of our RC, this is some of the activities that we have. I mean, before the COVID-19, before the MCO, we have very active organizing some physical activities. We inviting speakers from industry, from university, from locally, internationally, and also since we are working on the wireless technology, right? So we are very aggressive in actively in inviting the speaker from like the Webi, from the DG, Celcom, and few more. Okay, and as a conclusions from my sharing session today, we need to migrate. We need to migrate quickly to 5G to ensure this convergence of network technology application services are fully achievable one day. And also, 5G can serve as a flexible platform, as we know. That is very important. And also, what we do today is actually what we expect here is giving a better ROI, return of investment. For example, you have a grant. What we expect here, better return investments. Will goes to our country. Will goes to everyone. Okay, and also final word here is this is a very important industry revelation. Also, this 5G is a promising generation of wireless communications that can change our life, people life. Okay, so this is the reason why we have this kind of things. Okay, I think this is the end of my sharing sessions today. If you have, I mean, looking for the potential collaboration again, I share my phone number and also my address. So this is my email and also my phone number. If you have any projects that you think you can collaborate, you are welcome to join for to collaborate with our team. So on behalf of MMU and so IEEE, Comsat VTS, I would like to thank you very much to the organizer. I think I end my session with thank you very much. I pass back to the Mr. Chairman. Thank you very much.
All right, thank you, Doctor, for the informative and interesting presentation. Such a good info for Malaysian, I guess, that Doctor said just now, Malaysia will release the 5G technology very soon. All right, ladies and gentlemen, now we come to the question and answer session. But before that, if you haven't scanned the QR code, please do so. Okay, Doctor, now we have a question from the Q&A box. Okay, the question is from Mr. David. The question is, how developing countries can initially cope with challenge of budget in TVET for implementation of IR 4.0?
Oh, it's a very, very political question. Yeah, it's very, very challenging for, it's not for government, also for like us working in the university and also research institutes. Okay. This thing what we have to means we need the cooperation from everyone's. At first, we have to work in team. Again, we have to work in team. It's because when we work alone in our research domain, probably we lost for some part. So from there, we can share the resources. For example, what we have in our university, it can be used by other university with a very kind collaboration. And also, this is demanded, especially from, not from me, it's from TM, producing a low, low investment, high performance. Okay, this is actually the philosophy from the TM. So means we will produce low investment products. Will investment means a very, very low model. And then we try to come out with a better performance. So this is what we're trying to tell. So it's really needs a long plan to come up with this kind of plan. So this is we need collaboration from everyone.
All right. Thank you, Doctor, for your answer. Okay, for one more question. The question is, who should be course curriculum approval authority if course developed through collaboration of industry and institute?
Who should? Again, the questions.
Who should be course curriculum approval authority?
Curriculum
Course developed through collaboration of industry and institute.
Industry and institutes, for example, MMU and TM, maybe. Okay.
Maybe, Doctor.
Yeah. Okay. Actually, what we need actually is agreed by both parties. And for example, I'm talking in our cluster, okay. We are under wireless technology research centers. We collaborate with WEBI, we collaborate with ZTE, we collaborate with TMs. We are part under TM, Telecom Malaysia, which is our parents, and we have a MOA. We have a MOA between these two institutes. And before we come up with the MOA, of course, we must have a proper documentations. What the contribution come from our university, what's the contribution from ZTE, example. At the ends, maybe in terms of the intellectual property, will go to both, beneficial for both parties. So I mean, they must have a sort kind of a proper agreement.
All right, thank you, Doctor, for your answer. Such a beneficial session. Okay, thank you again, Doctor. So, all right, ladies and gentlemen, we are now moving on the last presentation. Okay, let's welcome our speaker, Mr. Amiruddin Zahamil, who is the Program Director, Asian Region Siemens, Malaysia. For your information, Mr. Amiruddin is also a former Senior Technical Training Officer at GMI Technical and a Process Test Engineer at Intel. The title of this presentation is Education Foundation for Automation Engineer. And don't forget to scan the QR code on the screen so that we can record your attendance. Okay, ladies and gentlemen, please welcome Mr. Amiruddin. Are you ready, sir?
Yes. Assalamualaikum and a very good afternoon.
Okay, so over to you, sir.
Okay, so thank you for the introduction. So it's great to hear that Dr. Madani mentioned about the 5G and Industry 4. So thank you very much. Okay, so now it's my turn, the last presenter. So I would like to say thank you to the organizer and then to invite Siemens Malaysia into this Industry Institution Engagement and Education Summit 2021. Okay, so my topic today is actually about Education Foundation for Automation Engineer, so under the scope of Industry 4.0. So the rise of the 21st century digital enterprise and Siemens solution, that how we could, look into this topic. Okay. Okay, so in the big picture, so let me share with you the different megatrends are shaping our world. Yeah. So we look at the first topic is actually about digitalization. Yeah. By 2020, 30 billion devices will be connected. So by 2025, the global volume of data we saw up to 163 zettabytes. So you imagine the number, the big data, the big equipment that will be connected and the data you produce. And then we look into the demographic changes. Yeah, the Earth's population will increase from 7.8 billion people today to 9.8 billion in 2025. So average life expectancy will be approximately around 77 years, and as per now, it's actually about 72 years. Okay, and then we look now at the climate change. In the summer of 2017, the Earth's atmosphere had the highest carbon oxygen immersed and concentration as in 800 years. Yeah? So you imagine that the changes that we are facing now. And then we look also at the urbanization. By 2050, nearly 68% of the world population will be in the city. So by today, it's only 55%. And let's look at the globalization. In the time span of 20 years, global export volume has more than quadrupled. In 2018, goods worth of US dollar 19.4 trillion were exported. So means that you see that everything is moving on. So where does our education and this one relate? So let me share you a big picture before we go into the topic. Okay, so I would like to share that the intense global change with a new dimension in social divide is pressuring existing system. So if you see here, we are divided by social divide, nationalism, popularism, and protectionism. So if you see in the globalization, digitalization, Brexit, America first is already divided us, and then we look into the urbanization, demographic change, Friday for Future, and so forth. Yeah. So this is make everything is more individualized. Okay. So under the UN agenda up to 2030, if you can see here, everybody is looking at 17 sustainable development goals to transform our world. Okay. So if you see here, country translate the SDG into national development plan. Okay. So we have from no poverty up to partnership for the goal. And then if you see here, companies are supporting countries in implementing their national priorities. So means that we are looking into all this topic, and then to make sure that all these 17 as best to suit as as much as possible. Okay. So if you see here, 17 SDG to transform our world, SDG by Siemens Impact. Yeah. So let's see. So impact via product and solution. Yeah. For example, like now, mostly direct impact through innovative product portfolio along the value chain through leadership. So we look at the good health, well-being, affordable and clean energy, industry, innovation and infrastructure, sustainable city, and communities and climate action. So this is the impact on the product and the solution. And then when we look into impact via sustainability and responsibility business practice. So we look into quality education, gender equality, decent work and economic growth, responsible consumption and production, peace, justice and strong institution, and partnership for the goal. Yeah, so this is the impact on the sustainability and responsibility for business practice. And then when we look into indirect impact, so means that SDG where Siemens has only limited and mostly indirect impact. So for example, like from poverty, zero hunger, clean water and sanitization, reduce inequality, life below water, and life on land. Yeah, so this is a very indirect impact for us. Okay, so just audience, I would like to share with you that our focus area in research and development is actually focusing on additive manufacturing, cybersecurity, material, autonomous robotic, data analytics, artificial intelligence, power electronic, blockchain, distributed energy system simulation and digital twin, connected e-mobility, energy storage, software system and processors, connectivity and edge devices. So I'm also later will talk about future of automation related to our topic whereby our automation engineer. Okay. So now we look here. So without TVET, TVET is technical and vocational education training. Yeah? Without TVET, sustainable development is hard to achieve. I can say here, Siemens contribute to society. And then a company has to have a purpose. That purpose has to be creating value for society. Yeah. And then you can see here, no development without any infrastructure. No infrastructure without any localization. No localization without any skills. And then, if you can see here, no skill without TVET. So if you see here, no TVET without the market data. And then it certainly doesn't hurt. Yeah. So it means that in terms of the education form that we have to look into. Okay. Okay. So what do we look into our automation engineer? So now what the focus that we are going to generate is actually the value in the next generation of the automation engineer, whereby this candidate needs to be understand and aware about the sustainability around you, and then this candidate also must look into the environmental responsibility. Yeah, and then the most important is actually the solidarity, means that you can work in a team, you can work multinational and across border. So this is the value that we look into. Okay, so how to say means that how you develop this type of talent. Yeah, it's actually the best is actually we can start from STEM, from the lower education, whereby discovery based learning is actually is a very good approach that we want to bring up the curiosity and the interest, yeah, whereby by using didactic, so means that didactic will have the experiment and they come up with the solution. Yeah, so discovery based learning is actually a one way, is very interesting for us to look at. Okay, so what we are building here is actually we want the future engineer independent character with sense of responsibility. So this is what we hope, the aspiration that the future engineer will come up into this independent character with sense of responsibility. Okay, so now a little bit more in depth, whereby I would like to share on you on this topic. Yeah, so on the manufacturing and the product life cycle, future of manufacturing and the digital factory, the path to the digital factory and industry 4, the Siemens solution, and then the automation system engineering and totally integrated automation. Okay, so the current practice, if you look here, the manufacturing life cycle bring a product to market start with research and development, yeah, for the manufacturing life cycle, and then it will come with the product design, and then we are looking at the process planning and installation, production quality control, market feedback, and then the loop goes and on and on. So this is the manufacturing life cycle, yeah, bringing a product to market. So this has been existing and been run all the while. Okay, so let's see now the future manufacturing, yeah, how the life cycle look like. If you see here, yeah, from number 1 to number 5, the product design is there, and then production planning, production engineering, production execution, and services. And each of the country, the main country in the world, for example, like Germany, they have the industry 4.0. So this is about manufacturing. And then for the United Kingdom, they have the rebalancing economy. And then for the United States, they have the manufacturing resurgence. And then China itself, they have from build in China to develop in China. So I mean, everybody have their own tagline. So for Malaysia, that we already introduced, that we have for manufacturing, we have the industry forward. Yeah. So this is Malaysia tagline. So now, if you look into the digital enterprise, so yesterday, so the process, yeah, if you can see here, it is in terms of the serial, something like waterfall. So you plan and then you wait, and then you develop, and then you wait again, and then build, yeah, you build, and then you get for the support. So it consumes a lot of time. And then what happened now, it means like today, it's already linked, yeah. So by looking at the future of the manufacturing, it's already linked. But what we want to achieve, yeah, is unified. So whereby from the product design, from the planning, from the production engineering, production execution, services are unified. Yeah. So it will combine, and then it will be how to say, very unified. Yeah. Okay. So now, if you see here, automation become more and more complex. So it will be more and more complex, whereby Siemens support the industrial enterprise worldwide in becoming more competitive. Okay, by strengthening the following key concept, by the software, the solution for the resource efficient production and industry integration. So why I'm sharing you here is actually the automation engineer need to prepare themselves, that they must learn. There's a lot of software that is available now in the market that they must be, how to say, focus, or they might need to seek for the software that been used in the industry. Yeah, okay. And then if you see here, for us, we integrate all the steps along the value chain based on the excellent industry software and automation component to improve productivity and efficiency. And for our target group, so the benefit for this is actually faster time to market. Okay, so the candidate, for example, like we are looking at the automation engineer, so they must be smart and focus on the what topic that they are looking for. So for example, they are more inclined for the software, so there's a lot of software. So I will share you in the next slide. Okay. So future of manufacturing. So if you see here, Siemens have a solution that we call Siemens Digital Factory, a comprehensive portfolio of seamlessly integrated hardware, software, and technology-based services that help manufacture increase competitiveness. Okay, so if you see here, what the aim is actually to significantly reduce time to market, greatly improve flexibility, reduce energy and resource consumption. So now, my advice to the young engineer or the future candidate, so it means that they must also look into this big picture, and then look into the storyline, and then pick the best that suit them. Yeah. Okay. Okay, so everybody already mentioned about the Revolution 1 and T4. So if you can see the past of the digital factory. So from the 70s, 17s, so based on mechanical production equipment driven by water and steam power. So this is how I can say the Revolution 1. And then when it comes to for the second revolution, so based on the mass production assembly lines and the use of electrical energy was introduced. And then when we come to the third revolution in the 1969, based on the use of electronics and IT to further automate production. And today, now here, we are based on the use of cyber physical systems. So this is what we want the manufacturing to look into. Okay. So a holistic approach, a holistic approach is necessary that cover entire supply chain. So whereby the product design, product planning, product engineering, product execution, and services are the entire supply chain, and it is all connected. And the supplier also are connected into all the supply chain. And then another one, a comprehensive suite of industrial software. So as you know that we are in the merge or in the journey into the industry 4.0. So we have a lot of software that need to be, shared with the education. So it means that for them to produce the candidate that are ready for the workforce. So on this topic. Okay, so let's see. So what we have. So means that whereby this automation engineer, so they can look into this topic also as a reference, for example. So for our software, we are looking at the product design, product engineering, supply, and so forth. So let's see one of it. So under product lifecycle management software, there's a lot of software inside here. So the candidate need to be well versed and exposed to this topic, whereby there is a product planning, design, test, and simulation, product planning, engineering, and simulation. So this is one of the few software that is available, and this is a top-down, a product-driven, whereby PLM software and automation product get to market up to 50% faster. So that's why you need to have the software. So means that now the education sector also need also to open to learn on this a new topic. Okay, so another one, we have the MES, or we call it manufacturing execution software. So whereby this software is actually doing on the planning and scheduling, quality management, manufacturing execution, manufacturing intelligence, and we look into SCADA and HMI, whereby the seamless integration in between the PLM and the automation world. So this is the integration software. Yeah. So MES or MOM is the real-time core element linking product lifecycle to automation. So this is also a key area for the automation engineer need to look into. Okay, so the third software that we have under digital enterprise is actually the industrial automation software. So whereby this is actually my core, is actually what we train in our country in Malaysia. So we push on the industrial automation software. So whereby the integration, engineering, and runtime of controller, distributed I/O, HMI drive, motion control, and motors. Yeah, so this is a software that combine all this. And then there's another topic also that is very important in the plant or industry, whereby the industrial safety and security. So this is bottom up and also a process driven. So I just would like to share with Siemens TIA Porter reduce engineering costs by up to 30%. So that's why most of our program that we offered to the to the mass population here in Malaysia, that for example, like for the bridging course for the university student, you know, so this is the software that we push, that at least the candidate are able to speed up their knowledge on the software. Okay, so okay, I would like to share also on in terms of the engineering cost management. Yeah, so let's see. Okay, so this is the total project cost. So if you see here, there's a hard cost whereby software, so product, license, seat, and then we have hardware whereby we have the controller, devices, component. And then in terms of the engineering, so this is where the job opportunity come. So whereby this is the engineering, whereby you do planning, design, programming, yeah. And then there is a soft cost. So this is where the automation engineer, or maybe the young candidate here, so that they are going into this workforce. So they also can look into all this for this, for example, maintenance, startup, debug, commissioning, integration, communication, screen generation, code generation, and miscellaneous. So this is the angle or the area that they can look into also. Okay, so this is actually a white paper from realizing human potential in the fourth industrial revolution. So if you see here, are we digital fluency now? Yeah. So this is a collaboration between private and public. Yeah. So and then if you see here, early exposure to the workplace and ongoing career guidance. Yeah. Are we ready? Yeah. So robust and respected technical and vocational education. Yeah. And then we will also professionalized teaching workforce. So means that the lecturers, yeah, the teaching force also must be professionalized. So that's why if the lecturer or the trainers are very professional, and then they can pass down their knowledge to the student or to the participant. And then another thing, are we future ready in our curriculum? Yeah, in our curriculum. So this is another topic that we should ponder upon. And a new deal on the lifelong learning. So this is actually now we are in the verge whereby lifelong learning is actually cannot stop. So we must keep on going to look into this lifelong learning. And then openness to education innovation. So this is the most important part. So if we are not open to the innovation, I mean the new way how to teach, how to deliver the information. So if we cannot do all this, means that we cannot persuade our young generation to become more innovate and more to become the innovation country. Okay, so if you look here, efficiency engineering is crucial for successful automation, yeah, whereby integration and a new portfolio make the difference in automation. So I just would like to share here. So for cost of engineering since 1979. So you see here, so it is somewhere here, yeah, engineering cost hour. And then when you look into complexity of the automation, yeah, is become more and more complex. Okay, and then we have total automation cost from 2010. So the dotted line here, so it keep on increasing by year. Okay, so what we want is actually engineering efficiency. So whereby by year 2010, we already start into the efficiency, even though the cost is going higher and higher, but the efficiency is actually is already stagnant. So for example now, so that's why we are very, focusing on the totally integrated automation, whereby we proliferate across Malaysia on this topic, whereby to minimize the engineering time and reduce cost. So means this is what the industry, or the industry is looking at, minimize engineering time and reduce cost. So that's why it's quite one of the, I can say, important topic. Through efficiency interoperability of all automation component. Okay, so integration is actually the key of engineering efficiency. So our candidate, or the future engineer, so must be well versed with integration. So how to do this? Yeah. So it's actually, if you can see here, so what is totally integrated automation? Yeah. So why we are looking into this is actually we have the consistent data management, global standards, uniform interface. So whereby TIA enable interoperability of all automation components. Yeah. So and then the best part is actually TIA is an open architecture that span the entire production process, which save time, reduce the cost, and boost flexibility. So if you can see here, so this TIA is actually span out into operation, control, and field. So for example, like the future engineer, for example, like automation, so in the field, so they they are able to control this. I mean the power supply, the industrial identification, RFID per se, distributed IO, drive system, industrial control. So they can focus for the instrumentation guy, for example. So and then we have a control in the control room. See, so there's also a control engineer whereby they look at the control, human machine interface, industrial PC on to the communication, motion, and CNC. So whereby this is actually controlled by the engineering. And then up in the operation level, whereby we have SCADA system and the energy management. So means that is actually the candidate can come from field or for the control perspective, or maybe on the operation perspective. And then it's actually how to do this is actually, this is the software is quite complete, to be taught or to be shared to the future engineer. So actually they are more versatile and can control all this. Okay, so I think I almost end to my slide, so I can share with you that the TIA create a real added value in all automation tasks. For example, that we are looking into the integrated engineering, whereby less time, money, effort due to consistent, comprehensive engineering in all phases of the production process. And then if you see here, industrial data management, and then the highest possibility decision making, maximize economical plant operation through the real-time access to the important data collected during the production. So means that even though this is software, but somebody need to do this. So means that the automation engineer need to very well versed on all this topic. It's not just about the automation part, but also on the data side. And then not to forget the industrial communication, whereby unlimited consistent communication, maximize transparency across all level by using international cross-vendor standards. So means that in the market there is a lot of type of communication, the field bus, the network. So means that the candidate need to be well versed on this topic. And then not to forget about the industrial security, whereby there is some hacking, malware, phishing, ransomware. So this is also a topic that the candidate also need to look into. Then we need some expert on this area. Not just on the this automation engineer must be well versed on this topic. So for example, they are looking at a systematic minimization of the danger of an internal and external attack on the plant and network. And then there is also safety integrated. For example, the machine guarding. So for example, that we have FMA 1967. So they are talking about the machine guarding and so forth. So this is implemented and digitalized, whereby it's built in the program. So whereby it can reliable protection of people, machinery, and environmental through the seamless integration of safety into standard automation. Okay, so just to sum up this, the candidate for the future of the automation engineer. So you must be well versed. So you need to be on a horizontal that you know most of the topic. Okay. So I think this is my end slide. Okay. So what I can see here is actually we support TVET as a mandatory creation in the education foundation. Okay, I think thank you very much for your attention. So I pass back to our chairman, Mr. Masrul. Okay, so
All right, thank you,
I
sir,
hope
for
I
that
don't bore
very
anybody because I
enriching
also the last presentation. So I
presentation.
hope
Ladies and gentlemen, with the
this is
end of
a
presentation
good
from Mr.
insight
Amiruddin,
that we
that
got.
means we have come to the end part of this session. As a part of committee, we would like to say thanks again to all speakers for the informative and interesting presentation along this program. And to audience, thank you for your active participation. Hopefully, this session will be beneficial for everybody. We would like to apologize if we have done any mistake during these 2-day summits. Once again, don't forget to scan the QR code for your attendance. I am Mazrul Azrin Aladdin, signing off. Take care, everyone, and stay safe. Thank you. Assalamualaikum and bye.